Hello, everybody. Hello, hi. Hello. Am I audible? All of you? How are you guys? Yes, I think I'm audible. And please check if my audio and video are visible and audible. Okay, good. చెప్పండి ఒకసారి అందరికి. Hi. So ఈ సెషన్లో we're gonna start with the waves chapter. చూసుకో. The biggest thing లేదా hi, good evening, good afternoon. Rather, good afternoon. అందరికి very good afternoon. Very good afternoon, all of you. And what I was telling you. Yes. Sir. What you are typing, ra? Huh? Sir. All clear, sir. Okay. Just a minute. There might be little disturbance, ra. Kani, it's getting sorted out. Choose. I don't know how to do this. Okay, sir. Good afternoon, everybody. Good afternoon. A very good afternoon. Right. Okay. చూసుకోండి. సో ఈ సెషన్లో మనం వేవ్స్ గురించి చూద్దాం. కానీ ఇట్ ఈస్ యాక్చువల్లీ అ వెరీ డిఫికల్ట్ చాప్టర్ ఫార్ లాట్ ఆఫ్ ద స్టూడెంట్స్. ఎందుకంటే వేవ్స్లో ఒకటే టైంలో దేర్ ఆర్ మల్టిపుల్ థింగ్స్ దట్ ఆర్ గోయింగ్ ఆన్ రా. అంటే దేర్ ఆర్ ఇన్ఫైనైట్ పార్టికల్స్, దే ఆర్ ఆసిలేటింగ్, దే ఆర్ వైబ్రేటింగ్ అట్ ద సేమ్ టైం. అర్థమైంది కదా? So if there are infinite particles oscillating at the same time, sir, how will you see infinite particles at the same time? Ante ide chala pedda problem. Okay, hi. So kabatti waves anedi, it is one of the most difficult chapters. I would not say most difficult, ra. Students feel, okay, students think that waves is one of the most difficult chapters. చూసుకోండి. కానీ ఈ సెషన్లో గుడ్ ఆఫ్టర్నూన్ ఎవ్రీబడి. కానీ ఈ సెషన్లో we will be trying to simplify this whole chapter and we will be trying to go to the depths of this chapter. కానీ the only thing that I want from all of you is attention. Okay, attention. Hi. The thing that I require from all of you is your attention. Hey, all I want from you is your sincerity, ra. Okay, sincerity. Okay, your attention, your sincerity. If I have that, we can start the chapter. Chusko. So, sir, what are the prerequisites, ra? Prerequisites ante enti? Ante what is expected from you to remember to study this chapter? And if you don't know that, if you don't know the prerequisites, hi, no problem. The lecture has just started. I did not tell anything. Okay, I did not tell anything. Just go. If at all you don't have these things, then you might feel a problem, ra. Choose code. The first one is your SHM. SHM ante enti ra? SHM ki equation kavali. Okay, you must know the equation, the acceleration of the particle in the SHM. And at the same time the energies also, sometimes the energies also, okay. Right. The second thing I want is your interference, leda you can say superposition of SHM. In the last lecture of waves, ra, hey, you see my waves lecture in the last half an hour. Okay, superposition of SHM, I have discussed this concept in the last half an hour from the waves chapter, all of you. Okay, So these two ante, these are your prerequisites andariki. These are your prerequisites. Okay, hi, hello. If you don't know this, then you will be facing a lot of problem in your waves. Okay, but I don't want that. I don't want my students to face a problem. Kabatti, we will quickly be seeing this also and this also. Okay, not much derivations ra, kani just the result part. Okay, just the result part we will be observing, all of you. So with that being said, all of you start cheddam me waves chapter. And each chapter kosame the first thing that required is your SHM. Chooskondira SHM ante enti sir? SHM ante simple harmonic motion. Simple harmonic motion lo oka particle ante it simply oscillates to and fro, left and right, leda up and down, leda cross and cross, leda cross and cross. But the only condition is it should oscillate to and fro. Are you understanding? Kani here when we are looking this simple harmonic motion from your waves point of view, we will only be considering the particle that moves up and down. Are you understanding? Idante chala important thing. You try to understand. Eppudu SHM chapter lo, when I was telling you about the motion of the particle, akkada we saw that the particle was oscillating left and right. Ide kada. So we told something about your mean position. Dan tarvata we talked something about your extreme positions. Ante kada, rendu extreme positions unnayira. Ante ee mottam scenario ni we have seen from the horizontal perspectives. Kani ee session lo we will be discussing everything of that in a vertical frame of reference. Ante my particle is starting from the mean position. Idante na first extreme position, this is my second extreme position, all of you. This point is x is equals to 0. Ide point ante x is equals to plus a. Leda you can simply say it is along the y-axis. So sir, we will be replacing this x with y. Ante y equals to 0. This point is y is equals to plus a. Idante y is equals to minus a. Chooskondi. This session will be going for at least 5 hours. Okay, 5 hours. So you are attending your biology from last 5 hours and physics for 5 hours ante 10 hours kavalira. So koncham energy tone kuchondi, all of you. Okay. good Choosko. So everybody jagrataga vinandi. Okay, the particle is oscillating up and down, something like this. Are you understanding? So this is the simple harmonic motion of the particle. Ante enti sir? That means the particle has different mechanisms. Ante enti ra? Let us first talk about the speed of the particle. Speed of the particle ante sir exactly at the mean point ra. Cheppu, what is the speed? Speed cheppandi andariki. If you don't know the formulas kavali. Ade, the simple terminologies are, these are all the formulas that we discussed in the last lecture. Last lecture ante me SHM lecture lo, these are the formulas that we have discussed. Chooskondi. First formula is for your speed. Sir, speed is omega into root of a square minus y square. Leda x square. Yedaina, in whatever axis your motion is happening, what you take the same. Ante if your motion is in x-axis, a square minus x square. Y-axis lo unte a square minus y square. Leda z-axis lo unte a square minus z square. Ardhamaindi kada? Yes. So this is the formula for the speed of the particle in SHM, simple harmonic motion. Chooskondi andariki. So if the speed has been completed, the formula for acceleration is minus omega squared into x. Kani this motion is in the y-axis and then acceleration becomes minus omega squared into y. Okay. Tondarga we will revisit each and every topic ra. Choosko. So ippudu I have to talk about the two scenarios ra. Two scenarios ante enti sir? The extreme condition for speed and the extreme condition for your acceleration. Extreme conditions ante enti sir? ante your maximum speed and your minimum speed ra ade similarly alage we will be seeing also for your acceleration ante acceleration maximum and here acceleration minimum ide kada. Yes, so me SHM lo gurtunda we actually made a proper table, and our table lo we have filled the values of the directions and the values ra ante when the particle was at the right of the mean position, the acceleration was acting in the left, and when the particle was in the left, acceleration was in the right. Ade kada ante eppadaina teeskondi the acceleration always acts opposite to the position ante displacement ra ade kada. Yes, chudandi. So maximum speed కోసం you substitute the value of Vmax అంటే ఇది కూడా నాకు maximum కావాలి. So when it becomes maximum అంటే your y should become 0 రా అదే. So your maximum speed Vmax is equals to omega into a అదే కదా. Yes, and minimum speed is 0 రా. 0, how 0 sir? When for minimum speed your y should become equals to a ra. Ide for minimum condition, this is for maximum condition, ante your y should be 0 for maximum speed and your y should be 0 for minimum speed. Okay, right, perfect. Ante if your y is 0, ఈ పాయింట్లో the speed is maximum. జాగ్రత్తగా అందరికి అదే కదా. Yes, and when your y is plus or minus a అంటే ఈ పాయింట్స్లో your speed is minimum, ఇక్కడ కూడా your speed of the particle is minimum. అంటే if you are seeing this particle in motion, this is the top position ra. Hey, this is the top position, this is the bottom position. అంటే when it is coming to top, speed 0, 0, 0, 0, 0, 0. Understanding? Kani at the center point, speed should become maximum. Okay, speed should become maximum at the center and 0 on the extreme positions. Paina ki, kinda ki. Okay, very good, all of you. What about the acceleration, sir? It is exactly the reverse of speed ra. Chuskondi. Exactly the reverse ante enti ra? The position at which your speed is maximum. Chuskondi. సెంటర్ పొజిషన్లో స్పీడ్ మాక్సిమం ఉంటుంది కదా, ఆ పొజిషన్లో యువర్ యాక్సిలరేషన్ విల్ బి మినిమం అంటే యువర్ యాక్సిలరేషన్ విల్ బికమ్ 0 రా అదే. సిమిలర్లీ వెన్ యువర్ స్పీడ్ ఈజ్ మినిమం, యువర్ యాక్సిలరేషన్ విల్ బికమ్ మాక్సిమం రా. ఇక్కడ కూడా యువర్ యాక్సిలరేషన్ విల్ బికమ్ మాక్సిమం అందరికి. యాక్సిలరేషన్ మాక్సిమం అంటే ఎంత సార్? యూ పుట్ ద వాల్యూ ఆఫ్ వై రా, వై ఎక్స్ట్రీమ్ పొజిషన్స్లో your y becomes a until your maximum acceleration becomes omega squared into a and your minimum acceleration becomes 0. Ide kada? Correct. Very good. Ante now I can say that I have a rough sketch ra. Andarki jagrataga chuskondi. So if this is my particle, all of you, okay, if this is my particle, oka single particle gurunchi maatladutunnu andariki. I'm only talking about a single particle in simple harmonic motion. Ade kada? Yes. So I'm only talking about a single particle in SHM ante it is moving up and down ra. Chuskondi. This single particle is actually moving up and down. Okay? It's moving up and down. Ippudu it is my first hand ante this is my right hand kada. This is my right hand. This is my left hand ra. My right hand, my left hand. ఏం చేస్తున్నంటే ఐఎమ్ మూవింగ్ లేదా ఐఎమ్ యూజింగ్ మై రైట్ హ్యాండ్. ఆల్ ఆఫ్ యూ జాగ్రత్తగా, ఐఎమ్ యూజింగ్ మై రైట్ హ్యాండ్ టు మూవ్ దిస్ పార్టికల్ అప్ అండ్ డౌన్ రా. అంటే ఇట్ ఈస్ అ సింగిల్ ఎస్హెచ్ఎం దట్ ఐఎమ్ గివింగ్ రా. చూసుకోండి, ఇదే నా ఎస్హెచ్ఎం కదా. ఎస్, what will happen if I use my left hand also ra? Ante when I am using my right hand, at the same time I will use my left hand to do two different simple harmonic motions. Chusko ra. This is SHM, up and down, up and down, up and down, up and down SHM. Idi kuda SHM, up and down, but these two SHMs are working differently. Ante enti ra? ఈ ఎస్హెచ్ఎం కోసమే టైం డిఫరెంట్, ఆంప్లిట్యూడ్ డిఫరెంట్. ఈ ఎస్హెచ్ఎం కోసమే టైం డిఫరెంట్, ఆంప్లిట్యూడ్ డిఫరెంట్. అంటే దే విల్ మూవ్ డిఫరెంట్లీ, కానీ రెండు బోత్ ఆఫ్ దెమ్ దే ఆర్ ఎస్హెచ్ఎం. అండర్స్టాండింగ్? ఎస్. సో వాట్ విల్ హ్యాపెన్ ఇఫ్ బోత్ ఆఫ్ దెమ్ they are acting on the same particle. Same particle ante enti ra? This is SHM, this is SHM acting on the same particle ante it will mix up. Mix ante a mixing procedure ni we will be calling as the superposition of simple harmonic motions. Chuskondi andariki. Okay. So we will call the superposition of simple harmonic motions. Okay, yes. Superposition of simple harmonic motion. Okay. Hey, what you're telling, Ra? Hey, what movie teaser has been launched, Ra? Huh? I was able to understand that Salar 2 teaser is going to release, Ra. Is it released, Ra? Salar 2 teaser released, Ra? Not released, right? Not released. Okay, so what teaser are you talking about, all of you? Okay, anyways, చూసుకోండి అందరికి, all of you. Okay. So in superposition lo, what we will do is we will take two different SHMs ra. Kani ee discuss chesin mundu kuda I will have to talk something about the equation of simple harmonic motion. Okay, equation of simple harmonic motion. What is the equation of simple harmonic motion? Can any one of you tell me, Ra? Can anybody of you tell me? What is the equation of simple harmonic motion? So if the particle is moving in the y-axis, choose what we discussed in our SHM lecture last class lo, your particle was moving along the x-axis ante back and forth kada. Yes, so this was the motion of the particle ra. X equals to plus a, x equals to minus a. Ide kada, and your particle is moving back and forth. Okay, right. So what was the equation andariki? The equation was being written. What did we write, Ra? Hey, cheppora, why are you so silent? We told, sir, x is equals to, cheppandi, it's moving too much, Ra. How to stop it from moving? Don't know. Anyways, chusko. So x is equals to a times of sine of omega t. Kani. This equation was coming with a condition. What was the condition, Ra? Em condition untundi cheppandi andari. Okate condition ante when you are only taking omega t, this implies that, yes, very good. This implies that the particle starts from rest. No, not rest. From mean position. The particle is starting from your mean position, Ra. Jagrataga chuskondi. Starting from mean position ante enti, Ra? Physics lo, I've told you in SHM chapter also. What did I say you? That there is nothing known as starting from or mean position, Ra. Ante enti, the particle already started. Kani when you are saying the particle our time low, that was exactly at the mean position. Are you understanding? Good. Very good. Ledante, if you are saying, sir, no, when I saw it, It started from a general point. So a general point kosame equation entante, you can simply say, sir, x is equals to a times of sine of omega t plus some phase constant phi ra. How to find? If phi ki value ela find cheyalante, you will be given with the conditions. Conditions ante enti, sir? This distance will be given to me. Ade kada? Yes. And starting ante t equals to 0 petkondi, x ki place lo ee distance value petkondi, you will automatically get your phi value. Okay, right. Ippudu, what I want to all of you to visualize is, if the motion is happening along the y-axis ra, andariki jagrataga vinandi, ante this becomes my y equals to 0. E point lo it becomes y is equals to plus a, and this becomes y is equals to minus a. Ante kada, chuskondi. X axis lo motion, y axis lo motion. Ardhamaindi? Yes. Any problem, sir? Any problem, sir? So equation is the problem ra. Equation is the problem. Endukante ippudu ee case lo your equation will be different. Different ante, instead of this x ra, ee x ke place lo, can any one of you tell me what will come here ra? Here, sir. Simple, sir. Here will be y. So the equation will be y is equals to a times of sine of omega t. Ade kada, idi kuda oka standard ante special case ra. Aim special case ante, when the particle is oscillating, okay? The particle is oscillating back and forth. Kani, when you are looking at it, it is starting from the mean position. Mean position ante y equals to 0. Main position ante y equals to 0. Ide kada, so it is starting from y equals to 0. Mari enti, sir? What next, sir? If the particle does not start from mean position, mari we will change the equation. How will we write the equation ante? A times of sine of omega t plus some phase constant phi ra. Ippudu phi ki value entante, it must be given to you, okay? It must be given as a condition ra. Chuskondi, if your particle is starting from y is equals to a by 2 ra. Ide kada, yes, it is starting from a by 2, going up, then going down, malli coming to the same and moving up and down ra. So ee case lo your t is 0. Enduku t equals to 0 ante, it has just started now ra. Just started now ante t becomes 0. And your y value anta icharu ra. Y value chuskondi okasari. A by 2 ante ఈ మొత్తం distance becomes a by 2. అంటే ఈ equation లో మీరు y కి value a by 2 substitute చేసుకోండి. What you get is a by 2 is equals to a sin phi. A gone. What you are left with now is, sir, 1 by 2 is equals to sine of phi. Ante your phi value comes out to be pi by 6. Ide kada? Yes. Chuskondi. All of you. Okay? So this is how you write the equation. Ante ఒకసారి మీకు వాల్యూ వచ్చిందంటే you substitute back into the equation ra. All of you, tell me. The equation reduces to y equals to a sine of omega t plus pi by 6. Ide kada? Yes. So this is the equation of your SHM particle ra. Kani this all is in the y-axis. Okay? Y-axis. Everything is in the y-axis. Y-axis ante enti ra? Y-axis ante your equations will be in the y format now. Y format ante enti ra? Y is equals to a sine of omega t. How was the exam? How was the exam? How much questions were attempted? Anyways, చూసుకోండి. Yeah. Okay, sorry. So now what we do is, we will be trying to take two different SHMs ra. This is the equation of my SHM. జాగ్రత్తగా వినండి. ఇదే నా first equation. This is my second equation. Okay. we will be trying to add them. Ante your y1 is equals to a1 sine of omega t and me second SHM ante y2 is equals to a2 sine of omega t plus phi. Ante enti sir? That means if this is your first hand moving up and down, up and down, up and down SHM. Ade kada, my right hand, my left hand, then our right hand, this is my left hand, my right hand is doing SHM. At the same time, my left hand is also doing the SHM ra. Rendu very SHMs unnai kada. Now what we are doing is we are clubbing these two SHMs into a single equation. Okay, we are clubbing these two SHMs into a single equation. Mari, when you are clubbing these two, the equation should also get clubbed kada, and it should also mix up. So that mixture of the equation, leda, that combination, we will be calling it as superposition, and for now we don't have time to derive all of it. Okay. So what I want all of you to remember is, చూసుకోండిరా, చూసుకో. Let us compare the two equations. అంటే మీ first amplitude is A1, మీ second amplitude is A2 రా, జాగ్రత్తగా వినండి. మీ first phase is only omega t and second phase అంటే omega t plus phi. చూసుకోండి. So what is variable అంటే first your amplitude is changing A1 నుంచి A2 వరకు. And your phase is changing ante omega t nunchi omega t plus phi varaku. Okay, so these are the changing things ante variable things. Okay, andariki. So now yeah, Bhanu, not completely, but this is whatever it's required. I'm covering. Okay, if you have not covered SHM, listen to this, that will be sufficient. Okay, right. Chemistry is difficult, huh? Depends, paper to paper. Okay, anyways, whatever questions you have for physics, you can ask me here. Okay, be it JEE Mains, be it JEE Advanced, we will solve it. No. Hey, let it be. We will try to see. Okay, ఇదే నా ఫస్ట్ ఈక్వేషన్ అంటే మై ఫస్ట్ SHM, దిస్ ఈజ్ మై సెకండ్ SHM. వేరియబుల్స్ చూసుకోండి. వేరియబుల్స్ అంటే ఏంటిరా? పారామీటర్స్ చూసుకో. మీ ఫస్ట్ పారామీటర్ అంటే యాంప్లిట్యూడ్ రా. ఓకే, అండ్ యువర్ సెకండ్ పారామీటర్ ఈజ్ యువర్ ఫేజ్. ఓకే, యువర్ సెకండ్ పారామీటర్ ఈజ్ యువర్ ఫేజెస్. చూసుకోండి జాగ్రత్తగా అందరికి. ఐఎమ్ నాట్ స్టార్టింగ్ ఫ్రమ్ దట్ టిపికల్ అండర్స్టాండింగ్ టైప్స్ ఆఫ్ వేవ్స్, యు నో, దట్ లాంగిట్యూడినల్ వేవ్, all those things. We will not do that. We will simply go start and from this, and then we will come to that your transverse and longitudinal waves, all these things. Okay, those are chiller topics ra. Okay, chiller topics చూసుకోండి here. So ఇప్పుడు మొదటిగా amplitude గురించి చూద్దాం రా. Your first amplitude is A1, మీ second amplitude is A2 రా, జాగ్రత్తగా all of you. Okay, but you cannot add these amplitudes directly. ఎందుకు యాడ్ చేయాలంటే sir, this is the first SHM, my right hand. This is the second SHM, my left hand. They are both acting. They are acting on the same particle. Ante ippudu we have to club them. Ante we have to join them. Ade kada. So that means, sir, SHM unte amplitude undali, sine equation undali, phase undali. Ade kada. Yes. So my first amplitude is A1, second amplitude is A2. When you are adding, what will be the resultant amplitude? Ade kada. Yes. So let us name that resultant amplitude as A net ra. Chuskondi. A net is equals to formula gurtupettukondi. Ippadi kosam, even if you remember the formula, that is more than sufficient. Okay. Formula entante, it is equals to root of A1 square plus A2 square plus 2A1 A2 into cos of phi. ఇప్పుడు ఈ phi ఏంటంటే, this phi is the phase difference రా, జాగ్రత్తగా చూసుకోండి. phase difference అంటే ఏంటి సార్? వాట్ ఎవర్ ఎక్స్ట్రా వాల్యూస్ ఆర్ దేర్. ఓకే, చూసుకో. ఫర్ ఎగ్జాంపుల్, దిస్ ఈజ్ యువర్ ఫస్ట్ ఫేజ్, ఇదే మీ సెకండ్ ఫేజ్ కదా. ఎస్. సో ఫస్ట్ ఫేజ్ సెకండ్ ఫేజ్ నుంచి డిఫరెన్స్ చూసుకుంటుంటే ఇట్ ఈస్ సింప్లీ ఈక్వల్స్ టు phi రా. phi. ఓకే, phi. And your phase becomes equals to sine of, take omega t common ra, omega t plus some value alpha. Ade. So when you are writing the two equation, it comes out to be y net is equals to చూసుకోండి net into sin of omega t plus some angle alpha. ఇప్పుడు alpha ఏంటంటే we will discuss it later on, okay? For now, ఇప్పటి కోసం I want this information from all of you, okay? Good. So let us start from your waves రా. Directly start చేస్తున్నా చూసుకోండి. మీ waves లో you have to understand a few things. They are very, very, very elementary things in your waves. What are they అంటే you try to understand, okay? ఇప్పటి కోసం we'll talk about waves on your string. String waves, string waves, sir. Yes. For now we will start with your waves on strings, okay? Ante string waves ra chuskondi. So it is your string andariki, all of you, okay? This is your string, okay? Have attached it from a rigid support ante from a wall ra. So ide me string. Now what I'm doing is all of you try to observe, okay? Simple harmonic motion gurtu pettukondi. Just put that motion in your mind ra. Up and down, up and down, up and down kada. Yes, up and down, up and down, up and down ra chuskondi. Ippudu I have a particle ra. This is my particle, okay? Jagrataga andariki. What is doing is this particle is moving simply up and down, up and down, up and down, up and down, something like this ra, okay? So what I'm doing now is it's a continuously moving particle ra. Idante continuously moving particle, up and down, up and down, up and down. So let us do one thing ra. Let us pick it and let us join it. Join ante welding ra. Weld ante glue, stick, join, glue, weld, whatever you want to do, you do it. Mari emaitadi ante this particle will move on, keep on moving up and down, up and down, up and down. Mari emaitadi sir, since the particle is joined with the string, ide kada? Yes, particle is joined with the string kabatti when the particle goes up ra, string also moves up. Ante enti ra, string looks something like this. Ade kada? Yes. When the particle goes little more up, చూసుకోండి అందరికి, when the particle goes up, ఏమైతుంది అంటే the string will also move a little up ra, all of you. The string moves a little up, something like this. Are you understanding? Hey, one more up ra, once again. ఇదే, this is the final position of the particle, అదే కదా? This is in SHM ra. Right, so corresponding to that final position, ఏమైతుంది అంటే this string will again keep on moving upwards, something like this, okay? So your particle was here, up. ఇప్పుడు when your particle is going down, ఇదే కదా, it has reached the amplitude, all of you, okay? When it has reached the amplitude, the next thing that we will be going to do is to bring it down. చూసుకోండి రా, ఇదంటే నా ఇనిషియల్ పొజిషన్స్. ఫైనల్ పొజిషన్స్లో ఏమవుతుంది అంటే యువర్ పార్టికల్ విల్ నౌ కమ్ డౌన్ రా. కమ్ డౌన్ అంటే ఇట్ ఈస్ కమింగ్ అట్ ద సేమ్ పొజిషన్, చూసుకో. కానీ ఇప్పుడు ఏమవుతుంది అంటే యువర్ వేవ్ లుక్ సంథింగ్ లైక్ దిస్ రా, ఓకే? చూసుకోండి, ఇట్ వాజ్ అట్ ద టాప్ బట్ యు ఆర్ బ్రింగింగ్ ఇట్ డౌన్ రా. బ్రింగింగ్ ఇట్ డౌన్ అంటే ఏంటి రా? దిస్ ఈస్ ద పొజిషన్ ఆఫ్ ద పార్టికల్ అందరికి. ఇట్ వాజ్ హియర్, యు ఆర్ బ్రింగింగ్ డౌన్ అంటే ఇట్ కేమ్ డౌన్. మళ్ళీ ఒక్కసారి what you are doing is you are again bringing it down ra, all of you are bringing it down. అంటే ఏంటి రా అంటే the string will look something like this, all of you try to understand, okay? అంటే this wave is traveling, wave, you should not say wave ra, this top point ra, peak అంటే amplitude is traveling to the right side, okay? ఇంకా మంచి కావాలా? వాంట్ ఈవెన్ బెటర్ దెన్ దిస్? చూసుకోరా, when it comes again down రా, when it comes down ఏమైతుంది అంటే the shape of the string goes something like this. అంటే ఏంటి రా? Are you understanding? When the particle is at rest, string అంటే it is completely horizontal. ఏం చేస్తున్నాం అంటే we are simply lifting this particle up. String lifted up, మళ్ళీ ఒకసారి lifting up, string lifted up, మళ్ళీ ఒకసారి lifting it up, string lifted up. Once the amplitude has been achieved, what we will do is we will move it down. Down ante the particle now will come down. The wave, this curved shape will be formed. When you are moving down, the curved shape will travel. When you are moving down, the peak will travel. Something like this. Ante kada? Yes. So if you are doing it continuously, all of you, if you are doing that continuously, up and down, up and down, up and down, emaitadi ante the string will look something like this. Ide kada? Yes. Ante entira? You are continuously oscillating it. Okay? You are continuously oscillating ante you are something is traveling. Ippudu I don't know what is that. Wave is traveling. Particles are traveling. What is traveling? I don't know. Okay? I don't know. Okay? I just don't know. So what we will do now is we will try to analyze. Chuskondi. The question is all of you try to understand. Okay? All of you try to understand. There are some statements, there are some statements I am giving to you. There are some statements that I am giving to you. The statement number 1. Statement number 1 entante in a wave chusko. In a wave. In a wave, energy travels. Okay? Energy travels, not the particles. This is ide ante chala pedda misunderstanding of most of the students ra. Okay? Me waves lo your energy is traveling, not your particles ra. Okay? The first statement. Statement number 2. Every particle, okay, statement number 2 is every particle in a wave, every particle in a wave performs every particle in a wave performs a simple harmonic motion. Next, statement number 3 statement number 3 is that చూసుకోండి. The speed of particles in a wave, okay, in a wave ante the particles that are doing the SHM particles ki speed is different, okay, is different than the speed of wave energy. Okay, and the last particle is energy travels in a wave ante me energy traveling kada from left to right side the energy is getting traveled. So if your energy is traveled ante your wave is trapped. Jagrataga gurtu pettukondi. Now let us take each and every assumption and try to derive some results in it. Okay, let us take each and every assumption and try to derive some results from it. Assumption number 1, what is it? Every particle in your wave kada, yes, every particle performs a simple harmonic motion. Ante me waves lo every particle is performing your simple harmonic motion. It is a very hairline mistake that the students do andariki chudandi. So ide me string unte, let us take a few particles on this string jagrataga vinu. First, second, third, fourth, fifth, sixth, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, and so on and so forth. Okay, these are the particles on the wave. Approve, all of you. What's happening is, let us say this particle stays here only kani this particle moves a little up. this particle moves a little up, this moves a little more up, little more up, little more up, little more up, something like this, okay, all of you. Now this particle over here comes down, little more down, little more down, okay. Here malli okkasari little more down, little more down, little more down, and this is the particle. Ante chuskondi, this is your wave. Are you understanding? Ippudu emaitidi ante the same particle will move up ra. This will also move up, this will move up, this will move up, this will move up, this will move down, this will move down, this will move down, this will move down, this will move down. Ante koncham samayam tarvata it is also moving up, it is also moving up. The shape looks something like this. Are you able to understand? After some time the wave shape looks like this. Ante enti ra? Ante every particle in a wave is simply doing SHM. This is also doing SHM. This is also doing SHM. And the resultant of the SHM looks something like the wave is traveling, okay? The wave is traveling, all of you, okay? The wave is traveling, something like this it looks. But kani, you see each and every point, okay? Ippudu I want you to understand only this point, okay? This finger of me, this finger of me, all of you, this finger of me. You understand? You listen to, you observe only this end part of my hand. Chusko. What is it doing, ra? Simply performing SHM. Chuskondi, up and down, up and down, up and down kada? Yes. It is simply performing SHM. At the same time you understand this hand ra, this part, idi kuda chuskondi, up and down, up and down, up and down kada? Yes. So this part is also doing SHM. Ante enti sir, in a wave every particle performs simple harmonic motion up and down. Ide kada? Yes. So ide me string unte, these are the particles on that string. Let us take a different color ra. Okay, altogether different. First, second, is a little thickness. Okay, third, fourth, fifth, sixth. These are the particles on the wave. Ante particles on the string. Now it is moving up and down. It is also moving up and down. It is also moving up and down. Not like this, ra. Chusko. When I say this is a wave, ra, after some time the wave looks something like this. Ante this particle has completed the maximum amplitude. Andariki jagrataga vinandi, okay? This particle has completed maximum amplitude. This particle has traveled this much of distance, ra. Ide here, this particle 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 here. These are the distances covered by each and every particles, okay? This is on the rope itself. Kani these particles now started moving downwards ante these are the displacements of each and every particle ra. Chusko. Ante kada? Yes. The question is, the particle will not stop. It will keep on oscillating. This also oscillating, this on oscillating, this also. Each and every particle will keep on oscillating. Ade kada? Yes. Shivkumar, Velu. Go. Okay, break kavalante leave the class. Okay. Take the full break, ra. Why are you giving your exams also, re? Huh? Take a break from your class. Take a break from your institute, from your exam, from your life. Pause it till you become 70 years old. Akkad nunchi continue chesko. 70 years tarvata go in the exam hall, NEET exam, and then write it. Sir, 70 years lo will become doctor. 80 years lo I will get married. Okay, wife's age 95. Your age 80 years. Go, do it. Okay, do it. Take a 70-80 years break, ra. Jagrataga. Okay, do it carefully. 70 years break teesko. After 70 years you start the class. Okay, this video will be on YouTube only. Okay, take a break for now. Go for 70 years. 70 years tarvata, sir, what is the name of the chapter? Waves, NEET, Telugu, Physics, Vedantu. Take you, sir. Time duration also, you see that, okay? You see the time duration also. And continue from this diagram. Okay? After 70 years, you come. Okay? Bye-bye. Anyways, chusko. So what's happening is, your particles are doing SHM. Ade. So this is the only thing. Ide kada? Yes. Right. So, sir, there are different SHMs that are happening. Ide kada? Yes. So there are different SHMs. And although there is a single string, each and every point on that string is performing your simple harmonic motion. Kada? Yes. So we will try to take a monitor point ra. Monitor point ante enti sir? Monitor point ante the point that we will be observing. Chuskondi andariki. Ante this is my wall, this is my string. Ade kada? Yes. Chuskondi. This point becomes my monitor point. Monitor point ante enti ra? Hey. Let us say this is not a wall ra. Chusko. Yeah, you will get confused more then. You will get more confused. This is my string, all of you. Okay? Ide na string ra. Should I tell you now? Yes. Whatever you want to eat, you eat. For example, a biscuit. Okay? For example, you are eating a samosa. Suddenly you feel acidity in your chest. It happens with you only. It happens with me only, or everybody of you. Hey, is it loading? Buffering? My goodness. Buffering. Not buffering, Ray. Not buffering. It's coming. Okay, it's coming. Yes. I'm telling so much important things over here. We are trying to write the equation of the wave, and someone amongst you wants the difference between your longitudinal and transverse waves. Okay, longitudinal and transverse wave. Okay, sorry. Good. Choose code. So what all I want to tell you is, each and every point is doing SHM. Ade kada? Yes. So let us say this is my monitor point ra. Monitor point ante enti sir? Monitor point ante enti sir? You are trying to oscillate this point with your hands only ra. Chuskondi andariki. This is the point. What you are doing is you are trying to oscillate this point ra. Ade kada? Yes. Chuskondi. Jagrataga, all of you, listen to me very carefully, okay? Listen. Y-axis. So y-axis lo me SHM unte, your equation would look something like this. Y is equals to A times of sine of omega into t. Ade kada? Yes. So this is the equation of SHM for the particle. Is it clear? Is my video clear, all of you? I don't see any problem, Ra. I don't know why you guys are seeing it. From my end, everything is good. Clear. Okay. Okay. Y equals to A sin omega t ante this is the equation of a single particle. Ade kada? Yes. Y is equals to A sin omega t unte this is the equation of a single particle. Ade kada? Yes. So what will happen ante, hey, let me focus on teaching, okay? Let me focus on teaching, all of you. Don't say that buffering. It will come. YouTube is not in my pockets, okay? I'm not going into your laptops and causing this buffering. Are you understanding? It's happening until there is some internet problem. It's happening until there is some technical problem. Koncham times the kosam you adjust it by yourself. You understanding? Sorry. What was I telling? Equation. Yes, equation. Okay, I was talking about equation, and this is the equation. What's happening is this is your wave ra. Wave ante energy traveling, okay? Energy traveling. Chuskondi. These points are fixed. What I want to tell you, I want to clear two misconceptions. First misconception is this point remains here only. Chuskondi. It is just doing up and down. It is not moving forward ra. What is moving ante energy is moving. Chuskondi. What is moving ante your energy is moving ra. But the point is fixed. Ide kada point is fixed. And let us say energy is moving with speed v. Jagrataga vinandi. Your v is the speed of the energy, okay? Yes. Your v is the speed of the energy, all of you. Let us say after time t. After time t, whatever the position of this particle is, it is continuously changing kadara. Chusko. It is at the bottom position ra. Chuskondi andariki. So whatever position of this particle is, it is going to repeat kada. Every single point is going to follow it. Endukante it is the leader ra. You are starting the motion from here. Every single point is going to follow it. Ade kada? Yes. Kani modatiga every single point had a simple position. Ante they were in a straight line. Each and every single point. Chuskondi andariki. Ippudu we started disturbing it. Ante entira? Whatever you do here, hey, try to understand. Whatever you do here, let us say this distance is x, okay? Let us say this distance ante it is x ra, x. Speed of energy is v. Andariki cheppandi. The question is how much time will the energy take? How much time will the energy take to go from here to here? Speed v unte, distance x unte, your time is equals to distance upon speed kada. Yes. This is chala important, okay? This is most important thing. Chuskondi. What's happening ante whatever you are doing here, whatever you are doing at this end, it will be reflected. Koncham samayam tarvata, after some time, whatever you are doing here, it will be reflected at each and every point. Ade kada? Yes. Kani, when you are talking about this point ra, ee point kosam, it will be reflected after x by v seconds. Can I say that? After the time of x by v. Yes. So whatever you are doing here, it will be reflected over here after x by v seconds. Ante what is the equation of this point? Point ante entira? Equation of the point at a distance x given the speed of the wave ante speed of energy is v. Cheppandi. Same format ra. Y is equals to a times of sine of omega into. Kani what should I take the value of t? Chusko. Can I say that whatever you are doing here will be reflected here after x by v seconds? Ante entira? Reverse it. Ante enti sir? Whatever this particle is doing now, whatever it is doing now, the same motion has already been performed by this particle before x by v seconds. Can I say that? Yes. So a particle kosam whatever time, let us say you are 10 seconds you are considering ra, this particle has done the same thing 10 seconds ago ante for this particle it will be 0. Ante enti sir? You are subtracting 10 seconds kada. Ekkad nunchi whatever the particle time t is there ra, you subtract minus 10 ante minus x by v. Ide kada? Yes. So chuskondi, y is equals to a times of sine of omega into t minus x by v. This is the equation of a general point. General point and dt, you change the value of x. Points will change. You are understanding? Yes. Ante enti ra, the equation looks something like this. A times of sine of omega t minus omega x by v. Simplify cheskondi. So this is the equation of a general point on the string. Ante that is the equation of wave itself ra. What is the equation of wave, sir? Y is equals to a sine of omega t minus x minus kx. Kani. This equation ra, idi kuda chuskondi, idi kuda. This is also a standard equation. Why, sir? Because this is the equation of this particle. SHM untundi kada. So SHM lo this is the equation. But what if this particle is not starting from rest. So if it is not starting from rest, ante entira, its general equation will be a sine of omega t plus phi kada. Yes, you take the same equation, instead of everything you add one more phase constant phi. Endukante we are assuming that the particles are starting from a general position. Chuskondi. This is your equation of a wave. Okay, this is the equation of your wave. Y is equals to a times of sine of omega t minus kx plus phi. I hope it's understandable, right? Okay, right. Now chudandi all of you. So when you have to talk about the equation of a wave, on a string, okay? Equation of a wave on a string. You understood the result? Good. You did not understand the result? Very good. Kani formulas gurtupettukondi. Okay, formulas ante entira, formulalu, what is the value, what is the significance of each and every term, eppudu use cheyali, ela use cheyali, you must be very well thorough with each and every of that thing. Okay, try to understand the formulas only. Andariki chuskondi. So if this is your wave, okay, this is your wave and traveling to the right, chuskondi, all of you. Although I told everything in your EM waves ante telusa, I told one point in that, right? If your wave is traveling to the right, you have different equations. Ade kada? Yes. Chuskondi. If your wave is traveling to the right, the equation looks something like this. Y is equals to a times of sine of omega t minus kx. Leda, take the negative of it. Ante entira, leda you can simply say y is equals to a times of sine of minus omega t plus kx. If you want to rewrite, you can rewrite it. Rewrite chesina tarvata, you will simply say y is equals to a times of sine of kx minus omega t. Same kada? Yes. Kx minus omega t. So this ledante this. They both are the equations of a wave moving to the right side. Okay, they both are the equations of the wave moving towards the right side. Chuskondi. You understanding this wave is moving to the right side. What about the wave that is moving to the left, sir? What about the wave that is moving to the left? Ante this ra. Ide. So this is your wave moving to the left side. Ade kada speed is v. Andariki jagrataga vinandi. So the equation reduces to y is equals to a times of sine of kx లేదా చూసుకోండి. So this is the equation of wave. Okay, perfect. So if at all you are getting two different equations, you try to understand. Okay, when the wave is moving to the right side, sir, why are you getting panic? Teach, be friendly and good. I am getting panic because you are not getting panic your exams ra. Hey, your exams are 3 months and you are not getting panic. Kabatti, instead of you, I am getting panic over here. Okay, you should not be able to sit now. You understanding? Your tension, your fear, anxiety and it should be at the highest levels. Okay? Kani, what you are saying is, sir, why are you getting panic, sir? Teach cool, teach friendly. Understanding? Some students make me laugh. Some students make me angry. And some students make me both. You are understanding? So I don't understand how to react at such instances. My half face angry, my half face laughing. Something like this. Okay. Okay. anyways, చూసుకోండి. Let us come to the topic, okay? Let us come to the discussion. Anyways. See, this is how I get distracted from the topics, okay? Let us see. So, hey, this was the equations, okay? చూసుకోండి. So you try to understand one thing, all of you. The particles are simply oscillating in the y-axis. అదే కదా? Yes. Particles are oscillating in the y-axis. Particles are oscillating in the y-axis. Kabatti, the letter y is here. And we are see the wave ante energy ra, energy is moving in the x-axis. Kabatti, this x term is here. Chuskondi. You must understand the significance y and x ra. If at all I tell you that your wave is something like this, okay? This is your y-axis and this is your wave. Chuskondi. And ide ante me x-axis ra, okay? And this is your y-axis. Can you tell me what will be the equation? Format cheppandi ade. Only tell me the format, all of you. Only tell me the format. So in case lo, your particles are literally moving in the x-axis. Ade kada, the SHM is happening in the x-axis. So the equation will look something like x is equals to a sine of omega t minus k into, kani the wave is moving to the y-axis kada. So yes, so it becomes ky. Ade, you are able to understand ra? Are you able to understand, all of you? లేదంటే you try to understand everything. ఇదే నా y axis and this is my z axis, okay? ఇదంటే నా z axis రా. Are you able to visualize? It's coming out of the plane, okay? Coming out of the plane. The wave is moving something like this towards plus z axis and the oscillations are happening in the y axis. Can you tell me the equation, all of you? Can you tell me the equation? Yes, very good. Very good. Cheppandi. The thing is, sir is handsome. Oh, nice. Nice. Okay. You know, I was applying in movies, Ra. But because of my bad acting, they did not take me. A sine omega t minus kx. No, Kanmani, just look your result, okay? Your answer is half correct, but okate, just a single variable is stopping it. Just a single variable. Check it. Not kx. The question is, I want to tell the approximate equation of this wave. Wave is traveling along z axis, ante by t ki, something like this, and oscillating up and down. Ante the wave is coming like this, towards you, okay? Towards you. This is the wave coming towards you, all of you. So what could be the equation of the wave? Cheppandi. Ade, I want the approximate equation of the wave. Very good. So చూడండి అందరికి. What's happening is the particle is oscillating along the y-axis kada. So equation will look y is equals to a times of sine of omega t minus k into, can you choose where the wave is traveling ra? Z-axis, and it should be minus k into z. You are understanding? Are you understanding? Yes, not y. Minus k into z, okay? Right, very good, all of you, very good. Let us take one more question and then we will be stopping ra. చూసుకోండి. This is my y-axis, ide na x-axis, this is my z-axis. The wave is moving something like this. చూసుకోండిరా, x axis కదా, this is my xy plane. Are you able to understand? Yes, the wave is moving something like this in the xy plane only. చెప్పండి. The wave is moving in xy plane only. Action movies, huh? No, I will do action movies. You are understanding, not understanding, ra. Abbo. Villain character, ah. Do I look like a villain, right? Really? No, hero. No, epudu I will become villain only. Okay? I will not teach you good. I will not teach you good. You will not understand. You will not understand. You will not write exam. You will fail. That's why I am a villain. It's not complicate. It's a compliment. Right. Thank you so much, everybody. Thank you so much for your love and support. I am a hero, not a villain, okay? Yes. Hey, Chapandira, what is the equation? Let us come back to the discussion, all of you. Time is wasting, right? Hey? Time is wasting. Choose. So your equation, yeah. Fine. So the particle is moving in the x-axis and xy plane lura. So your equation will start from x is equals to malli okkasari ade same teesukondi a sin of omega t. Kani the wave ee case lo your wave is traveling to the negative z axis kada. So negative z axis lo unte no negative z axis lo unte you will take a plus sign. Endukante negative unte both should be either plus leda both should be either minus. Ade kada? Yes. Okay, yeah. So a sin omega t plus k into this axis ra z. Ade. If you are understanding, well and good. Ledante you take some more questions of this same format and try doing them, okay? Take the same questions. Same questions ante enti sir? See, take xyz axis ra, ide na y axis, x axis, z axis, okay? Take any wave, something like this, leda like this, leda like this, leda like this, leda like this, or like this. These are the combinations that you will be taking, and try writing the equations, okay? Try writing the equations. Okay, right. Next, chudandi. Now let us just go to the equation of the wave, okay? What was the equation of the wave, ra? Ela ochindi? Okay, this was something we were talking about, right? Yes, this. Chuskondi. The actual equation of the wave is ide. This ra. Chuskondi. Ikkada nunchi you can simply say that omega v k. Omega v k. What is the link between omega v and k ra? Can I simply say, sir, your omega by v is equals to k. So ekkada nunchi can I simply say this side, sir, omega upon k is equals to v. Chuskora. Ide v ante enti? Okay, but I think that should be solved. Yes. Am I clear? Yes, I think I am clear. Perfect. Choskora, all of you, okay? You try to understand this. So if the equation of your wave is something like this, y is equals to a sine of omega t minus kx. You try to understand that your k is nothing but omega by v. అదే కదా, ఇక్కడ నుంచి you can simply say sir v is equals to omega by k. v అంటే ఏంటి sir? v is the speed of wave. Okay, yes. Yeah, Isha, hi Isha, hi, I'm fine. ఇప్పుడు చూడండి, let us take the class at 0.75 speed రా. 0.75 speed లో I'm fine. Okay, anyways let us come continue. Leave it. So I'm getting distracted from my discussion. Okay, don't make me distracted, all of you. Chusko. So these are the formulas. Okay, let us compare with another equation. Chuskondi. So your equation is y is equals to 10 sine of 5t minus 7x. ఇప్పుడు చెప్పండి, the speed of the wave. What is the speed of the wave? Direction of the wave. The question is, ఈ equation లో you have to find, the question is find speed and direction of the wave. చెప్పండి. ఓకే స్పీడ్ కూడా కావాలి, డైరెక్షన్ కూడా కావాలంటే సింప్లీ గో ఫర్ యువర్ స్పీడ్ ఈజ్ ఈక్వల్స్ టు ఒమేగా అపాన్ కే. ఇదే కదా. వాట్ ఈజ్ ఒమేగా చూసుకో. ఈ ఈక్వేషన్లో వాట్ ఈజ్ ఒమేగా అంటే యువర్ స్పీడ్ ఈజ్ ఈక్వల్స్ టు ఒమేగా అంటే యూ కెన్ సింప్లీ సే సార్ కోఎఫిషియంట్ ఆఫ్ టైం. ఇదే కదా. ఎస్, omega is coefficient of time. What about k ra? K చూసుకో. It is coefficient of x కదా. Yes, so coefficient of x అంటే displacement, ఏదైనా తీసుకోవచ్చు. Okay, yes. So JEE students are also there రా ఈ chat లో. Fine. చూసుకో. omega upon k అంటే coefficient of time 5 divided by coefficient of x అంటే 7. 5/7 meter per second. This is the speed రా. Direction చెప్పు. 1 is plus, 1 is minus అంటే the wave is actually moving towards the right. Do it. I will be back in 5 minutes. Okay, 5 minutes లో చూసుకోండి. Done. All of you done? Not done. చెప్పండి. So, direct answers. Correct. అర్థమైంది. You have next. So with that being said, all of you, we will try to move to the wave particles రా. Particles of a wave చూసుకోండి. Particles of wave అంటే ఏంటిరా? Particles of wave అంటే you have two scenarios రా. First scenario లో your particles, they are continuously doing SHM. చూసుకోండి. It's not a live wave రా. కానీ when you talk about a live wave, just give me a minute, okay? Just give me a minute. You might face a little problem, కానీ that will be resolved in 2-3 seconds, okay? All of you, that problem will be resolved in 2-3 seconds, okay? Not possible. Let it be. Right, perfect. So when you're talking about a particle of a wave, all of you, చూసుకోండి అందరికి. So this is a particle of the wave కదా. Yes, it is moving completely up and down. Equation చెప్పండి sir. Equation is y is equals to a times of sine of omega t minus kx. ఇదే కదా. Yes. This is the equation of the wave. ఇప్పుడు what we are doing is we are going to write the speed of the particle రా చూసుకో. It is very important result, okay? Speed of a particle in wave. సో పార్టికల్ స్పీడ్ కావాలంటే ఏం చేయాలిరా చూసుకోండి అందరికి. సో ఇఫ్ ఐ వాంట్ ద స్పీడ్ ఆఫ్ అ పార్టికల్ అంటే దిస్ పార్టికల్ ఈస్ కంటిన్యూస్లీ మూవింగ్ అప్ అండ్ డౌన్ అప్ అండ్ డౌన్ అప్ అండ్ డౌన్ కదా. ఎస్, ఇట్ ఈస్ మూవింగ్ కంప్లీట్లీ అప్ అండ్ డౌన్. మరి ఏం చేయాలంటే యూ రైట్ ద డిస్ప్లేస్మెంట్ లేదా పొజిషన్ ఆఫ్ ద పార్టికల్. వాట్ ఈస్ ద పొజిషన్ రా? y ఈక్వల్స్ టు a sin omega t minus kx. దిస్ ఇస్ పొజిషన్ కదా. యూఆర్ టాకింగ్ అబౌట్ ద స్పీడ్. ఏం చేయాలి సార్? డిఫరెన్షియేట్ చేసుకోండి. అంటే స్పీడ్ ఆఫ్ ద పార్టికల్ ఈజ్ ఈక్వల్స్ టు dy by dt. అదే కదా. ఎస్, are you able to understand? Actually it should be only the partial derivative of this position, అంటే del y by del t. అంటే ఏంటిరా? you only differentiate it with respect to time. చెప్పు all of you, what is it? It is equals to del by del t of y ఏంటి సార్? a sin of omega t minus kx. if you are understanding, well and good. లేదంటే results గుర్తుపెట్టుకోండి. your speed of the particle comes out to be a omega cos of omega t minus kx. అదే, this is the speed of the particle in your simple harmonic motion. okay, right. next చూసుకోండి all of you జాగ్రత్తగా. so the question is a wave oscillating as y is equals to 10 sin of 70 minus 5x full stop. Find the maximum లేదా find the speed of the particle. okay, find the speed of particle at the position అదే. this is a question. okay, తీసుకోండి అందరికి. you take it. I have to find the speed of the particle. particle అంటే ఏంటి సార్? particle అంటే this is your wave. all of you understand it very carefully. okay, it is continuously in motion. లో ఉంటే the wave energy is traveling to the right and the particles are oscillating up and down కదా. yes, particles are oscillating up and down, wave is moving to the right. అంటే you can simply say that take somewhere as origin రా. అంటే if you are taking this point as origin అంటే ఏంటి సార్? the oscillating point with which you are doing the SHM. Are you understanding? yes. hi. ఈ పాయింట్ నుంచి you are taking a distance of 5 meters. అదే కదా. yes, x is equals to 5 meters అంటే this 1 2 3 4 5 let us say this is 5 meter distance రా. అందరికి చూడండి, ఈ 5 meter distance లో ఉన్నది let us say this is the point, all of you. ఇదే ఎప్పుడు దిస్ పాయింట్ పొజిషన్ హ్యాస్ బీన్ ఫిక్స్డ్ రా, కానీ ద స్పీడ్ ఈజ్ నాట్ ఫిక్స్డ్. ఎందుకంటే ఇట్ ఈస్ డూయింగ్ SHM, కంటిన్యూ SHM. అంటే ఇట్ ఈస్ మూవింగ్ అప్ అండ్ డౌన్ అంటే స్పీడ్ ఈజ్ ఆల్సో వేరియబుల్. మరి ఎప్పుడు కావాలంటే t ఈజ్ ఈక్వల్స్ టు 4 సెకండ్. ఒక్కసారి మీరు పొజిషన్ ఫిక్స్ చేసి టైం కూడా ఫిక్స్ చేస్తుంటే యూ కెన్ సింప్లీ సే యూ కెన్ ట్రై టు ఫైండ్ ద స్పీడ్ ఆఫ్ ద పార్టికల్. కానీ మీకు స్పీడ్కి ఫార్ములా కావాలిరా. ద స్పీడ్ ఆఫ్ ద పార్టికల్ ఇన్ అ వేవ్ ఈస్ గివెన్ యాజ్ a omega cos of omega t minus kx. cos kada, did I write cos? sorry, yes, cos of ade. okay, so that is the speed of the particle ra. చూసుకోండి. అంటే what is the value of a sir? the value of a is 10. చూసుకో, y is equals to a sin omega kada. yes, the value of a is 10. omega value అంటే coefficient of t ra 7 into cos of చెప్పండి omega value omega అంటే ఏంటిరా omega value is 7 t value ఎంత ఇచ్చారు క్వశ్చన్ లో 4 minus k into x కదా what is the value of k sir k value is coefficient of x ra x 5 multiplied by position is 5 meters అదే కదా yes so it becomes 70 times of cos of 28 minus 25 28 kada 28 minus 25 becomes 3 ra cos of 3 ante you try to understand okay this number they are in the radians numbers are in radians ra radians lo unte you will have to convert into degree kada yes so ela convert cheyalante you multiply this 3 radian with pi by 180 లేదా 180 by pi kada it is already in the radians ra radians ante 3 radians so aim cheyalante you can do one thing ra you can divide it by 180 లేదా the best way is something like this 3.14 is pi kada so what will be the value of 3 if you are able to understand do it ledante leave it ra this is the speed of the particle are you understanding the only concept that I want all of you to understand is the formula ide this is the speed of the particle in a wave that is doing SHM ra SHM you understanding yes ante enti sir the first result that I want all of you to remember is speed of particle is del y by del t చూసుకో అంటే del y by del t అంటే ఏంటిరా this entire formula what is the formula sir a omega cos of omega t minus kx this is the speed of the particle ఇప్పుడు చూడండి all of you let us take a picture of a wave ra picture of a wave అంటే ఏంటిరా లేదా you can simply say yaar you are fixing a time interval let us say you are fixing a time అంటే ఏంటిరా at t is equals to 2 seconds you pause everything right at t is equals to 2 seconds exactly 0 tick 1 tick 2 at 2 seconds you are pausing everything and your wave looks exactly like this you are able to understand ఇప్పుడు no particle is doing SHM ra everything has been stopped ante you have been paused the entire scenario చూసుకోండి ఈ సినారియోలో the particles are only differentiated according to their displacement ra displacement అంటే their positions ra చూసుకోండి ఇది అంటే my origin x equals to 0 this is my random particle ra distance let us say x is equals to 2 meters let us say here the distance x is equals to 4 meters అదే కదా yes so only thing is you will changing the distance అదే time equals to slope కావాలి slope అంటే ఏంటి సార్ slope is the rate of change of the values of y with respect to x you understanding yes అంటే ఏంటిరా అంటే you can simply say sir the slope is equals to m is equals to dy by dx రా కానీ ఈ కేసులో since the value of time has been fixed you don't differentiate time రా del y by del x చూసుకోండి so your value of del y upon del x comes out to be like this రా a into k into minus a into k into చెప్పండి sin derivative of cos omega t minus k into x ఇదే కదా so this is your slope అంటే del y by del x జాగ్రత్తగా అందరికి so what I want to tell you is you pick this result then you pick this result all of you try to merge them ra చూసుకో let us compare both the results ra velocity of the particle vp okay is it clear okay so velocity of the particle in a wave ante vp it is equals to del y by del t ante a omega cos of omega t minus kx what about the slope ra slope is equals to del y by del x andariki ante minus a into k by k omega by k speed of the wave ante your speed of the particle by slope is equals to minus v of the wave ra చూసుకోండి so you can simply say sir speed of the particle is minus slope multiplied by speed of the wave ade this is a relationship between speed of the particle that is moving up and down and speed of the wave that is moving back and forth ra చూసుకోండి ఇదే this is a relationship చూసుకోండి how many of you are understanding and how many of you are not understanding Ardhamaindi? Right. Right. So we have talked about the speeds of the waves also. We also talked about the speeds of the particles also. The question is, you try to understand, okay? The question is, find where the particle P is about to move. Ide kada? Yes, చూసుకోండి. So if this is your wave, right? This up or down, up or down, up or down. ఎందుకు ఎంత ప్రాబ్లం వస్తుంది వచ్చేసి what's the same problem in your biology class also? I'm so sorry, Sana. I'm so sorry, okay? Kani, it's not in my hands, okay? I don't want all of you to have this inconvenience. Kani, things are not in my hands. Let me just verify. Why is it so much of problems? Clear, correct. How will you do it? There are two methods to decide it, okay? There are two methods. The first method is you check the previous point. Ante entira previous point of this point P. Where is it? Just direction cheppandi. Previous point ante in the right side or in the left side. Chusko. I'm telling you to observe the previous point. Ade. Previous points ante entira, the previous points solely, purely the previous points depend on the speed of the wave. Ante kada? Yes. Ante if the wave is traveling to the right side, the previous points will be to the left. Ante kada? You understanding? Yes. So if the wave is traveling to the right, ante your wave is moving to the right, then your previous points will be to the left. Ade kada? Ledante if your wave is moving to the left, something like this, చూసుకోండి. If this is your wave moving to the left, the previous points will be to the right. Previous points ante entira? Previous points ante the points at which the motion has already happened. చూసుకోండి. Okay, the question is that what are the previous points? All of you. Ante this becomes my previous point. Ade kada? Yes. Ippudu you see the speed of that previous point. Speed ante entira? Direction of the motion. I would not say speed. I would not say speed. Chusko. So can I simply say, all of you try to understand, okay? It's a little tricky topic, okay? The question is, this peak point, amplitude A is there kada? So this amplitude, it is traveling to the right. Chuskondi. Enduku wave is traveling to the right kada? Amplitude kuda it is traveling to the right. Ante koncham samayam tarvata this point has to take the position of the amplitude. Ante it must move upwards kada? Are you understanding? The speed of the point must be in the upward direction. Right? Good. All of you. Very good. Ippudu, with that all being said, let us go to the basic topics. Basic topics ante enti ra? Types of waves. Okay. But before that, let us also consider some things. Okay. Some things. Chuskondi. So if you are talking about waves on string, andariki. If you are talking about waves on string, there are some things to talk about. The first thing, modatiga, you consider some terminologies, all of you. Let us say this is a small particle. The mass of this particle is mp. Small particle, mp kada? Yes. So this particle is moving up and down, up and down, up and down. There are two things. Okay? Yes. The particle that is moving up and down, it has two different things. The first thing is it has the kinetic energy. Jagrataga vinandi. Ide kada? Yes. Kinetic energy. Enduku sir? Because it has got some mass. Ante string lo oka point undi kada. So it has got some mass and also moving. Kinetic energy is simply equals to half into mass of the particle into velocity of the particle whole square. Ide kada? Yes. At the same time, there will be a potential energy. Potential energy. How, sir? It's a spring. Not a spring. Chusko. The wave, for sure, it is not a spring. Wave ante the string is not a spring. Kani. What's happening is, you try to understand from this scenario. Chusko. This was the total length of the wire. Ide kada? Yes. Ee total length lo the wave leda. The wave has been formed something like this. Now my basic question to you is, you only consider about the length only. Only length choose. The first length is this one. Choose. This. The second length is this. This. Total length. Which one is greater? Which one is greater? Do you think both are equal lengths? They can't be. Mathematically speaking, this pink colored string, both are strings, okay. Okate string undundi kada, but when it is in a motion, the string is taking this shape ante when it is taking this shape, the distance is fixed kada. E end points lo distance fixed unte, you can simply say that whatever this string was here, it took a curved shape ekkada kuda whatever the straight string was here, it took a curved shape. Kani ee process lo the length of the string has increased. Ade kada? Yes. So if the length L dash has increased and L dash is greater than L, that means there is an elongation in the string. Vinandi. There is an elongation in the string. Ante entira, there must be a potential energy. Why? Because there is an elongation in the string. So, epadaina mee daggara elongations unte, you treat that string as a spring. Ardhamaindi kada? Yes. So, you treat the string as a spring. There is an elongation in the string. Okay, there is an elongation in the string as it is conducting wave. Ade wave. Ide kada? Yes. So if kabatti we treat this string as spring. Ade kada? Yes. Kani you understand, it's a very complicated phenomenon. I don't want to go into the details. Chuskondi. Each and every point ante small distances, they do extend via different lengths. Ante enti sir, if you are talking about only this length, chuskondi, this length, ante let us say this length is dx. Jagrataga chuskondi andariki. The same length has been elongated. Chuskondi. Apply the same limits. Ide kada ide. Similarly, other dx length would have been elongated by other displacement. Ante there is too much complications. Kani, ippadikosam what we are going to do is, we are going to take the small length dx and whatever the elongation has been there, ante total length is dl. Chusko. Total length is dl, this length is dx. The potential energy is half into k into x square. X square ante enti half into k into the elongation. What is the elongation, sir? Elongation is dl minus dx whole square. Ide kada? Yes, dl minus dx whole square. So idante your chinna potential energy du. Chuskondi. the first energy your wave is having is a kinetic energy. Endukante particles are there, mass is there, mass is moving ante kinetic energy. The second energy that your wave have is your potential energy. Your potential energy andariki chuskondi. So all of you, ఇప్పుడు we are defining some terminologies. Terminologies అంటే ఏంటిరా చూసుకో. First terminology is mu. Mu అంటే మీ linear mass density. Okay, linear mass. I would not go into the proof of each and everything. Okay, I'm just giving you the formulas. మీరు ఆ formulas గుర్తుపెట్టుకోండి. So if this is your string, all of you, your mu is equals to the total mass of the string capital M divided by the total length of the string. Ante this is the length L. ఈ మొత్తం length లో mass M has been distributed uniformly. చూసుకోండి. Okay, perfect. So you can simply say mu is equals to total mass of the string by total length of the string. So this is your value mu ra. Idi చాలా important. So whenever we are using this terminologies, we'll be using the same process. Okay, same mu only. చూసుకోండి. Now let us talk about the kinetic energy of the wave. చూసుకో. What is the kinetic energy of the wave, sir? Sir, kinetic energy of the wave is half into mass of the particle multiplied by speed of the particle whole square. ఇదే కదా? Yes. So if this is your string, andariki, the wave is traveling, okay, until the particles are moving up and down. So idigo, you can take a very small displacement. Let us name that very small displacement as dx ra. Okay, mass of the particle mp ante enti ra? Mass of the particle is, I'm simply writing mu into dx. If you are understanding, well and good. If you are not understanding, just gurtupettukondi. Mu ante enti ra? Total mass by total length. Ante you got a unit mass length ra. You multiply that unit mass length with the dx, you get the dx length lo unte mass. Okay, whatever it is there. So mu into dx is the mass of the particle. Substitute ra. So small kinetic energy, chinna kinetic energy, dk is equals to half into mass of the particle ante mu into dx, all of you, multiplied by velocity of the particle whole square. We calculated each and every single thing. Chuskondi. Velocity of particle ante enti ra? Chusko. This is the velocity of the particle kada, a omega cos of omega t minus kx whole square. Right. Substitute the same ra. Velocity of the particle ante a omega cos of omega t minus kx whole square. Adhe omega t minus kx. This is the speed kada? Yes. Whole square. Adhe cheppandi okasari. It's half mu dx multiplied by a square omega square cos square omega t minus kx. You're understanding? So this is your kinetic energy dk, small kinetic energy, right? Ippudu if you are sending that dx that side ra, so you have small kinetic energy per unit length. Kinetic energy per unit length is half mu a square omega square cos square omega t minus kx. Ippudu chudandi, what the biggest problem we have is we have to substitute each and every displacement ante position of each and every particle, and we have to substitute each and every time. Ante enti ra? If you want the average energy, andariki vinandi, if at all you want the average kinetic energy, you will have to substitute different points. Chala complicated ade kada. But we have one shortcut in mathematics. What is the shortcut ra? Cheppandi. Do you know the shortcut? How many students are watching? 17. Yes. But what I was telling you? Yes, I was telling you that if at all you have to calculate, this is the final formula. Okay, idante the final formula for the energy, kinetic energy of the small mass per its length. Ade kada, meeku total kinetic energy kavalante, you take the average values of it. Average values ante enti sir? Average value ante you can simply say, sir, the kinetic energy per unit length of a particle kani, that should be average, is equals to half, what was the formula ra? Half mu a square omega square. Ade kada? Yes, half mu a square omega square cos square omega t minus k into x. Okay, so this, it's not average ra, we'll take average కానీ చూసుకో, this is your kinetic energy కదా, ఈ మొత్తం అంటే మీ kinetic energy, but coincidentally ra, hey, there is a coincidence. What is the coincidence, sir? Your potential energy is also same as your kinetic energy. You're understanding? The potential energy ante, it is exactly the same value, same expression, same values ra as your kinetic energy. Ante you can also say, sir, your potential energy, chinna potential energy du per unit length dx is given as చెప్పండి same values ra, half mu a square omega square cos square minus kx. It's a coincidence. I'm not going to the proof of it, right? It will cause you a huge headache. You're understanding? We take a lot of approximations over there, but you just remember, okay, this is the potential energy per unit length of a wave. Ante meeku total energy kavalante, what you do ra, total energy per unit length dx is simply add both of them. Ade kada, add both of them. Ante half gets cancelled ra, 2 times kada same ఉంటుంది, 2 times ఉంటే 2.5 are gone. Simply equals to mu a square omega square cos square omega t minus kx. చూసుకోండి. But the biggest problem is this energy is changing with respect to time and with respect to position కదా. Yes. So మీకు average values కావాలంటే what you do is, in mathematics we do have a shortcut. The shortcut says that average value of sin square theta లేదా cos square theta, they are equals to 1/2 ra in the interval 0 to 2 pi. Not required. Choose. The average value of cos square is half kada. Yes. That means if you're talking about average values ra, చూసుకోండి, when you're talking about average values, ఈ మొత్తం converts to half, this also converts to half. చెప్పండి. So half అంటే ఏంటి రా? Your average value is 1/4 mu a square omega square. అదే. You're understanding? ఇక్కడ కూడా మీ యావరేజ్ వాల్యూ ఏంటంటే 1/4 mu a square omega square, right? Completed. చూసుకోండి. And we are talking about the total energy. This all converts to half kada. Yes, so you can simply say half mu a square omega square. Ade, this is your total energy per unit length. It's very important questions, okay? Very important formulas, all of you. జాగ్రత్తగా వినండి. So even if you have these formulas and the questions are being asked, you can directly write the answers, okay? Sometimes it's asking kinetic energy, sometimes asking potential energy, sometimes asking the total energy also. Formulas గుర్తుపెట్టుకోండి. When a particle is oscillating in a wave, చిన్న particle ఉంటే its kinetic energy is given as half mu a square omega square. A అంటే amplitude, omega is the frequency at which you are oscillating. Omega, simple harmonic motion nunchi omega is 2 pi by f kada. Yes. So you can find easily ra, omega values will be given to you. No problem. Everything will be given to you. Mu also it will be given to you. అర్థమైంది అందరికీ? Let us take a question లేదా let us simply take a question రా. చూసుకో. Question is a string of mass 100 kg and length 200 meters is held at one of its ends. Full stop. At one of its ends, and the end is oscillated in vertical SHM, okay? In vertical SHM at 20 times per second. అంటే ఏంటిరా? This is the string. This is the fixed end. Ante this is your this end is your holding point ra. You are holding it here and you are oscillating it. ఎంత టైం రా 20 times in 1 second. ఒక సెకండ్లో 20 times you're oscillating it like this. You're understanding? Yes. The question is, hey, not the question. Find the energy per unit length of the rope if the maximum displacement చేయండి. Okay. Yes. The break starts from 6 p.m. Okay, let us take a break at 6 p.m. 6 నుంచి 6:40 వరకు there will be a break. ఓకే చూద్దాం. సో ఒక్క సెకండ్లో 20 కదా, సో యువర్ ఫ్రీక్వెన్సీ ఈజ్ 20 హర్ట్స్, అంతే కదా. ఇక్కడ నుంచి యూ కెన్ సింప్లీ సే ఒమేగా ఇస్ 2π/f. సార్ హౌ డిడ్ యూ యూజ్ దిస్ ఫార్ములా అంటే, గో అండ్ విజిట్ యువర్ SHM చాప్టర్. ఓకే, SHM నుంచి దిస్ ఫార్ములా హ్యాస్ బిన్ డిరైవ్డ్. రైట్, కరెక్ట్. సో యువర్ ఒమేగా ఇస్ 2π డివైడెడ్ బై ఫ్రీక్వెన్సీ ఇస్ 20 అంటే π/10 రేడియన్ పర్ సెకండ్. ఇదే కదా. ఎస్, మీ దగ్గర యాంప్లిట్యూడ్ వాల్యూ కూడా ఉంటుంది, ఇట్స్ 2 meters కదా. ఎస్, అదే. సో యువర్ కైనెటిక్ ఎనర్జీ dk, టోటల్ ఎనర్జీ కావాలి కదా. ఎస్, సో టోటల్ ఎనర్జీ dE డివైడెడ్ బై dx ఇట్ ఈస్ ఈక్వల్స్ టు ½ mu a square omega square. అదే. ఓకే, మ్యూ వాల్యూ ఏంటి సార్? మ్యూ ఇస్ ద మాస్ పర్ యూనిట్ లెంత్. మాస్ పర్ యూనిట్ లెంత్ అంటే మ్యూ ఈజ్ ఈక్వల్స్ టు టోటల్ మాస్ divided by total length. Mass is 100, length is 200 అంటే mu value is 1/2 వచ్చింది. సబ్స్టిట్యూట్ చేసుకోండి, అదే. సో యువర్ హాఫ్ మ్యూ కూడా హాఫ్, amplitude is 2 అంటే 4 square multiplied by omega square అంటే pi square divided by 100. ఇదే కదా? చూసుకోండి. So your half 4 is gone ra. Pi square by 100, approximate take pi square as 10 divided by 100 is equals to 0.1 joule per meter. Okay, 0.1 joule per meter. How are you getting it? Oh, sorry. Hey, I'm sorry. Omega is not 2 pi by f. Sorry, time is 2 pi by f. Ra. Oh my goodness. Omega is 2 pi f. Very good. I'm really sorry. Omega is 2 pi f. Very good. Okay. 2 pi by t. Omega is 2 pi by t. I got little hey, something was going on in my mind. Ra. Just so it is 2 pi into frequency is 20 and 40 pi. Ra. 40 pi is your omega value. You can simply say, sir, energy is half dE by. Very good, all of you, very good. Okay, dE by dx is half mu a squared omega squared. And half mu is half a is 4 into omega squared is 1600 pi square. Ade kada? Yes. Gone ra. So it's 1600 pi square is approximately 10 ante idi teeskondi. 16,000 joules per meter. Okay, right, చూసుకోండి. So this is how you talk about it, right? Are you able to understand? Right. So let us take one more question, all of you. Question is like this. Four I cap, okay? Speed is 4 I cap. తీసుకోండి. Pi value 9.8, pi square. Pi value is 9.8 something. I just made it. Let me just verify. ఎందుకంటే I don't want to waste the time. చూసుకోండి. Energy density కదా అంటే dE by dx. Amplitude did I give you? substitute. dE by dx ante 200 kada, yes. 200 is 1 by 2 into 1 by 2 into a square into 2 pi f ra. Omega is 2 pi f kada, yes. So 2 pi is 2 pi, frequency is 4 upon pi, pi gone. So it is 8, omega is 8 radian per second. Substitute 64. So this is 4 ra, this is 64, 16 is remaining. So 200 divided by 16 is equals to a square, ante a is equals to, cheppandi, 200 by 16 ante it is 100 by 16 ante 10 by 4, 10 by 4 root 2 ante 5 by 2 root 2. Ide kada? Yes, meters, if I am not wrong. Right, correct, 5 by 2 root 2. So the equation is y is equals to a times of sine of, చెప్పండి, omega t minus kx. ఇదే కదా. ఎందుకు మైనస్ సార్? బికాస్ ద స్పీడ్ ఈజ్ ఐ క్యాప్ అంటే రైట్ సైడ్ లో రా. సో యువర్ ఈక్వేషన్ షుడ్ లుక్ సంథింగ్ లైక్ దిస్, 5 root 2 by 2 multiplied by sine of omega వాల్యూ ఆల్రెడీ వచ్చింది 8 కదా, 8. omega is 8t minus k కావాలి ఇప్పుడు. సో మీ k కోసం యూ కెన్ సింప్లీ సే సార్ k is equals to omega upon v. ఇదే కదా, yes, k is equals to omega is 8, v is 4 అంటే that is equals to 2 రా. డైరెక్ట్లీ సబ్స్టిట్యూట్ చేసుకోండి. సో యూ కెన్ సింప్లీ సే minus 2x. అదే, సో దిస్ ఈజ్ యువర్ ఈక్వేషన్ ఆఫ్ wave. 5 by root 2, no, 5 by 2 root 2, 5 by root, not 2 root 2 ra. Yeah, something like this. Okay, something like this. Pi anyhow gets cancelled, you don't have to take the pi value ra. Okay, right, sorry. So ఇప్పుడు we are done with your energy. I want the power, okay, power of a wave. చూసుకోండి. So your total energy per unit length అంటే dE upon dx ఇది వచ్చింది కదా, yes. How much is it sir? 1 by 2 mu a square omega square. అంతే. What I want is I want the power now. Power అంటే ఏంటిరా? Your power is equals to your energy dE upon dt. ఇదే కదా, yes. I only want this ra, I only want this. చూసుకోండి. సో ఇప్పుడు ఏం చేయాలంటే you simply do like this. Your dE by dx multiplied by dt by dt. ఇదే కదా, I'm just multiplying, dividing. You do it. అంటే you club these things together, all of you. And let us try to calculate the value of power. ఇదే కదా, yes. చెప్పండి. What is the value of power, sir? So your power is simply equals to dE upon dt. ఇదే కదా, your dE upon dt is equals to, చెప్పండి, లేదా your dE upon dt multiplied by dt upon dx is equals to half mu a square omega square. You understanding? Right. Your dt upon dx, it will go and become dx by dt ra. చూసుకోండి. So your dE upon dt అంటే power ra, power is equals to half mu a square omega square into dx upon dt. dx upon dt అంటే ఏంటి సార్? dx is the displacement in the x axis, not y axis. Particles are oscillating in y-axis ra, కానీ the displacement of the wave is happening in the x-axis. So dx by dt is the speed of the wave, wave, not particle, speed of wave. గుర్తుందా? Yes. So your power is equals to small చిన్న power dp is equals to, చెప్పండి, what is it ra? లేదా I simply say power is equals to, చెప్పండి, what is it? Power is equals to half mu a square omega square into speed of the wave, not particle. Okay, speed of the wave. ఇప్పుడు వాట్ ఈస్ ద స్పీడ్ ఆఫ్ ద వేవ్ అంటే యూ మస్ట్ బి అండర్స్టాండింగ్ ద ఫార్ములాస్. లేదంటే యూ కెన్ సింప్లీ సే సార్ పవర్ ఆఫ్ ద వేవ్ ఇస్ ఈక్వల్స్ టు హాఫ్ మ్యూ వి ఏ స్క్వేర్ ఒమేగా స్క్వేర్. అదే, ఇట్ ఈస్ ఆల్ ఐఎమ్ టాకింగ్ ఇన్ టర్మ్స్ ఆఫ్ యావరేజ్ కండిషన్స్. యావరేజ్ కండిషన్స్ గుర్తుందా? వీ టుక్ ద యావరేజ్ వాల్యూ ఆఫ్ సైన్ స్క్వేర్ అండ్ కాస్ స్క్వేర్ రా. వేర్ డిడ్ ఇట్ టేక్? హియర్ చూసుకోండి. సో ఈ యావరేజ్ వాల్యూస్ తర్వాత వీ హ్యావ్ గాట్ దిస్ ఫార్ములా రా. Are you understanding? Yes, we are talking in terms of average values only. If you don't want the average value, you remove this half and you say power is equals to mu v a square omega square cos square omega t minus kx. So this is actually the power formula. Kani, this formula is your average power formula. Okay, we will be using only this formula for now. Chuskondi. How is it 5 by root 2 Sujal Swarupa? A and A amplitude kada? Yes. So you have to divide it. d by dx is half mu a square omega square. d by dx is given 200, half mu value is half a square omega square ante 2 pi f kada? 2 pi f, frequency is 4 by f. Pi gone, 4 into 2 becomes 8. Omega is 8, omega squared becomes 64, so it is 464 ante 16. It converts to 16 ante 200 is equals to 16 a square. A square is 200 by 16 ante a squared is 4 4s are 16. 50. 50 by 4 kada. 50 by 4 ante 50 is 25 into 2 divided by 4. Take the square root. 25 is 5 divided by 2. Root 2 is there. 5 by 2 into root 2 should be the value of your amplitude. Okay. Yes. Next. Right. So this is your average power. Okay. This is your average power. Power in a wave ante this. Formulas you remember it. Okay. You just remember. Okay. Yeah. You can take it. You can take it whatever you want. You can take it. You can take it. Next. Let us talk about intensity. All of you. This is chala important. Before the break only, I want to cover till your intensity, and if possible, I also have to cover your interference of the waves. Okay. Yes, చూసుకోండి. Now we are interested about the intensity. జాగ్రత్తగా వినండి, all of you. Okay, all of you. You try to understand what I'm telling. This discussion, whatever we have did, it is not restricted to the waves on a string. Ante for sound waves, light waves kosam kuda, your EM waves kosam kuda, this is all the discussion. For your power, for your energies, for your stuff. Okay, energies and power. Chusko. The only thing that will be changing is this mu. This mu is linear mass density, and when it comes to different factors, it changes accordingly. Okay. But remember this formula, it is not restricted for waves on a string. Understanding? Sorry, చూసుకోండి. ఇప్పుడు let us talk about intensity. Intensity అంటే ఏంటిరా? Intensity is what? What do you mean by intensity? Intensity is nothing but the strength of the power. For example, you try to understand, okay? Hey, all of you. It is my light source. Ide na light source unte, it is reflecting the light particles at each and every direction. Ide kada, in all 360 directions. But the problem is, how many rays I am able to grasp ra? Ante, enta rays na eyes lo ostundi. Ade, ide kada? Yes. So let us say your first observer, it is standing somewhere here ra. Ante, this is the eye. Understanding? This is your eye. First eye, E-Y-E-I, okay? This is the first observer, ide your first eye ra. You take something like this. So this is your eye. Yeah, you're watching it from here. Let us say the distance from this to this is small r. Ippudu emaitadi ante, let us take the second observer somewhere here. But before that, let me just shrink it a little. Your second observer is standing somewhere here. This is your I2. Ide kada? Yes. And let us take the total distance is equals to capital R. The question is, which eye will see the light more dark? More dark ante more shining. The question is, which eye I1 or I2? I1 or I2? Yeah. Small r, correct. I1 ante this is my I1 ra. Okay, first eye. Endukante chuskondi. Why? Because for sure the answer is I1 ra. Okay, the answer is I1 will find more intensity. లేదా more shiny, అదే కదా. Why sir? Why? Because understand. Now I'll tell you something, okay? ఈ బల్బ్ అంటే ఇట్ ఈస్ ఎమిటింగ్ సమ్ పవర్ P రా, చూసుకోండి ఇదే కదా. yes, power P. Now what we have to do is we have to take the intensity. What is the formula for intensity sir? Intensity formula is simply equals to power upon area. What area ra? Area ante the area enclosed, the area enclosed by the point source, ade kada. yes, area enclosed. I should not say area, it should not say enclosed, I should say area surrounded around source. This is your area. అంటే ఈ observer కోసం, you understand R is the radius కదా. yes, you take the same area for a circle R. ఇప్పుడు చెప్పండి రా, what is the value of intensity I1 రా? I1 is power upon area 1. area 1 is the sphere రా, sphere. all 3D sphere ఉంటే you can simply say sir 4 pi R square, అదే కదా. yes. What about intensity 2 ra? Intensity 2 is the intensity for the second observer. Ante this is your second observer and for him this will be the area. Ante R value increased kada. yes. So it is equals to power upon 4 pi into capital R square. చూసుకో ఇప్పుడు we are comparing I1 and I2 values ra. Intensity 1 and intensity 2, it is power upon 4 pi R1 square. It is equals to power upon 4 pi R2 square. Power 4 pi constant. Power 4 pi constant రా, చూసుకోండి. Intensity is inversely proportional to radius whole square, ఇదే కదా. yes. So this is your intensity. అంటే it is inversely proportional to radius square. Why radius square? అంటే your area is in 3-dimensional రా. 3-dimension ఉంటే your sphere is the only possibility. కాబట్టి area of the square is 4 pi R square. And intensity is inversely proportional to R square. అర్థమైంది అందరికీ? yes. So this is your intensity. జాగ్రత్తగా వినండి all of you. అంటే ఏంటి రా? intensity is equals to power upon 4 pi R square. Are you understanding? all of you? okay. సరే good. Should I tell you about the solid angle? Yes or no? Sorry. Okay, anyways, what I was telling to you is here, చూసుకోండి. Let us add one more slide ra, and let us talk about intensity is equals to power upon area ra. Power upon area, ఇదే కదా. yes. What is the formula for the power of a wave in a string? Formula గుర్తుందా? Do you know the formula రా? చెప్పండి ఒక్కసారి. What is the formula sir? Formula is half mu v a square omega square divided by a. అదే కదా. So this is a formula for your power. That is the formula for your area. చెప్పండి. No, I'm not telling. Don't worry. No, I'm not telling. Solid angle not required for you, ra. Not required. Okay, it will get too complicated and time will get wasted. So there are some topics for solid angle. Actually, it's really not required for you, to be honest. But let us see. Still, if possible, in wave optics, we will discuss about it. Okay. So, sir, ఈ ఫార్ములా నుంచి AA gone kada. yes. So you are left with your intensity is half mu v square a omega square, అదే కదా. So this is your intensity sir, right? So this is your intensity of the wave. Okay, what is the formula? yes, the formula is intensity formula is half mu v square a into omega square. అర్థమైంది అందరికీ? Some complex reactions are happening in our minds, sir. You're not able to understand anything. Okay? You're not able to cope up with anything. This A is for amplitude, and this A is for area. How you can cancel out? You can't cancel out. Ardhamaindi andariki. This A is for amplitude. A sin omega t. A is for area. You can't cancel out. Understanding. You can't cancel out. Ho. Choose. So power is half mu v omega square A square divided by area is A. Choose. Okay, right. What is mu? Mu is total mass of the length, mass of the rope divided by length of the rope. Ade kada? Yes. You simply substitute this value into this formula. Ippudu cheppandi, intensity is half mu ki place lo total mass upon total length of the rod into speed of the wave multiplied by omega squared A squared divided by, ippudu area is area only. I am not writing A because you will cancel it out. Okay, I'm scared actually. Ippudu చూసుకోండి అందరికి. So your rope looks something like this. Okay, so this is the area of the cross section, and this is the length of the rope. Ante what you can say, sir, area into length. Area into length, cylindrical shape untundi kada. So area into length becomes volume. Ade. So your intensity is half. Cheppandi, what is it? Mass upon volume, mass upon volume. Sir, mass upon volume, sir. Mass upon volume multiplied by speed of wave into omega squared into A squared. Mass upon volume. Density is equals to mass upon volume. Right. So your intensity is equals to half. Density is rho kada. Mass upon volume is rho. V A squared omega squared. Ade. Right. So this is your intensity. Right. If you want, you can substitute the value of omega. Omega is equals to 2 pi f kada. Yes. So you can also simplify this. Intensity is half rho V A square into 2 pi f whole square. Ante you can simply say it's half rho V A squared 4 pi squared f squared. You can simplify it to be 2 pi squared A squared f squared rho V. Okay, this is the formula for your intensity. If you want, you can write it that also. If you want, you can write that also. So your intensity I is equals to 2 pi squared A squared f squared rho V. It's a little complicated, there are too many terminologies. Kabatti, you remember this formula. So this is the intensity of a wave. Okay, right. So this is the intensity of a wave. Not only wave on a string, ఏదైనా wave తీసుకోవచ్చు. Rho అంటే density. So if you have a sound wave, density of the material. If you have a light wave, understand? Okay, sorry. Good. What is the time, Yes, 6 p.m. is the time. So let us take a break from 6 to 6:40. Okay, after the break I will tell you type of the waves, right? Transverse wave, longitudinal, all these things. Okay, sorry. So this is your break time. After break, we will talk about some important terminologies. Ante interference of the waves, minima, maxima. Then we will talk about your sound waves also. And then we will talk about standing waves. Standing waves tarvata organ pipes. Okay, and that chapter will be completed. Sir. Hello, 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 everybody. Hi, hi, hi. Just give me a minute, okay? All right. All right, all right, all right. Let us continue the discussion. Okay. Hi, good evening, good evening, good evening, everybody. I am very well punctual, kada. Exactly came at 6:40 ra. Okay, perfect. ఇప్పుడు let us talk a few more things రే చూసుకోండి అందరికి. If you understand, if you don't understand. Okay, చూద్దాం. గుడ్. సరే. ఇప్పుడు ఐఎమ్ జస్ట్ రైటింగ్, ఓకే? ఐఎమ్ జస్ట్ రైటింగ్ అండ్ ఐఎమ్ నాట్ సేయింగ్ ఎనీథింగ్. మీరు చదువుకోవాలి వాట్ ఎవర్ ఐఎమ్ రైటింగ్, ఓకే? చెప్పురా, వాట్ ఆర్ ద డెఫినేషన్స్ ఆఫ్ ఈచ్ అండ్ ఎవ్రీ వన్ ఆఫ్ ఇట్? చెప్పండి ఆల్ ఆఫ్ యూ. చెప్పండి, వాట్ ఆర్ ద డెఫినేషన్స్? your transverse waves, they are oscillating up and down, moving forward. Ante మీ transverse wave లో the direction of propagation of waves is perpendicular to the oscillations of the particles. అదే కదా? Yes. This is the definition of transverse waves. అంటే ఏంటిరా? ఈ transverse waves లో your particles oscillate in one direction and your wave goes in another direction. అదే కదా? Yes, something like this, right? Your particles are oscillating up and down, but your wave is traveling perpendicular. కానీ longitudinal waves లో your particles are oscillating in the same direction and the wave is also going in the same direction. Okay, something like this. అదే చూసుకోండి రా. Mechanical waves ante the waves that needs material to travel. Sound waves, it needs air. Okay, it cannot travel in vacuum. Ra. The best example is string waves ante it must need a string. Non-mechanical waves ante the waves which do not require any medium ante EM waves. EM waves ante enti sir? Your radio waves, your all of that. Okay, all of your light is also type of EM wave. జాగ్రత్తగా వినండి అందరికి. ఓకే, ఎస్. సరే, దాని తర్వాత let us see about some attributes of waves ra. Okay, these are all the basic things not required actually, but still some of you would say, sir, you did not even tell us about the types of waves, sir. What chapter did you teach it, sir, if you are missing waves ra? Attributes ante the first attribute is your wavelength. Okay, yes, సరే. దాని తర్వాత the next attribute is your frequency, and lastly it is speed. Wavelength ante entira? The distance between, I would not say distance between, I would simply say wavelength is nothing but the total length of a wave. Ade, so this is the length of the wave, usually represented by lambda. Ade kada? Yes. Frequency is how many waves are being generated in 1 second. 1, 2, 3, 4. Not like this, right? Do you count the waves like this? No, you can't. You don't count the wave. It is one wave, completed. 2 waves, 3 waves, and all these things. Okay, so in 1 second, how many waves are calculated? This is known as frequency, represented by letter small f. Speed is equals to v is equals to f into lambda. Remember, good petkondi. These are the elementary formulas, all of you. Okay, yes, the unit of wavelength is meters ra. Okay, lambda counted in meter. The unit of frequency is time inverse. Okay, 1 by t, or it is equals to meter per second. LT minus 1. Chusko. Now, let us talk about your interference of waves. Okay, interference guరించి మాట్లాడతాం. చూసుకోండి రా. But even before that, even before your interference, let us talk something known as phase of a wave. చూసుకోండి అందరికి. Okay, phase of a wave antaru. What do you mean by phase of a wave? Quickly let us go through this ra. Jagrataga vinandi andariki. Phase of a wave ante, let us say this is your wave that started from the origin. Something like this, okay? Something like this. You try to understand, everybody. And this is your second wave. Ante rendu waves unnai mee daggara. Your first wave is going like this, and me second wave, it is something like this. Are you understanding? Similar waves kada? Yes. Similar phases ante at the same time they are going up also, and at the same time they are going down, at the same time they are going up. You are understanding? Ante these waves are in the same phase. Are you understanding, all of you? Yes. What about opposite phase ra? Okay, so let me just write here, these waves are in the same phase. Okay, right. What about the waves are in opposite phase? Andariki chudandi. Opposite phase lo unte this is your first wave and that is your second wave. Ante kada? Yes. So ippudu let us talk about the first phase. Ante ide, this is your first phase of a wave మీ సెకండ్ వేవ్ కోసం ద సెకండ్ ఫేజ్ లుక్స్ సంథింగ్ లైక్ దిస్, ఆల్ ఆఫ్ యూ. అదే కదా, ఎస్. అంటే when the first phase was topmost, the second wave, when the first wave was having the maxima, the second wave is minima. When the second wave is having, first wave is having minima, the second is having maxima. First having maxima, second having minima. అదే కదా. So these are opposite phases రా, చూసుకోండి. ఇప్పుడు let us talk something known as in phase and out of phase. Okay, in phase waves and out of phase waves రా. In phase and out of phase చూసుకోండి. In phase అంటే the phases are same, అంటే this are your in phase waves చూసుకోండి. అదే కదా, సేమ్ ఫేజ్ లో ఉంటుంది వేవ్స్ రా. ఓకే, అవుట్ ఆఫ్ ఫేజ్ అంటే దే ఆర్ నాట్ ఇన్ ద సేమ్ ఫేజ్. అదే యూ కెన్ సింప్లీ సే దట్ అవుట్ ఆఫ్ ఫేజ్ లో యూ కెన్ ఆల్సో సే దట్ ద వేవ్స్ దే ఆర్ నాట్ ఇన్ ద సేమ్ ఫేజ్. అంటే దిస్ కుడ్ బి యువర్ ఫస్ట్ వేవ్, దిస్ కుడ్ బి యువర్ సెకండ్ వేవ్. జనరలీ రా, జనరలీ. ఓకే, జనరలీ దే ఆర్ నాట్ ఇన్ ద ఫేజ్. అదే కదా, ఎస్. ఇప్పుడు let us talk about interference of waves. అందరికి జాగ్రత్తగా వినండి. ఓయ్ all of you let us talk something about interference of waves రా, చూసుకోండి. ఇంటర్ఫరెన్స్ అంటే ఏంటిరా? That means on a single string you are going to pass two different waves. Are you understanding? ఒక సింగిల్ స్ట్రింగ్ లో when you try to pass both లేదా multiple waves, then we talk about interference of the waves. చూసుకోండి. Let me just tell you about the cases రా. The first case of the interference is చూసుకోండి. The first case is your constructive interference. Okay, constructive interference అంటే ఏంటిరా? That means the waves they are in the same phase. Constructive interference అంటే ఏంటిరా? Constructive interference అంటే the waves must be in the same phase. సేమ్ ఫేజ్ అంటే ఏంటి? ఇప్పుడు let us do one experiment అందరికి experiment. సో ఎక్స్పెరిమెంట్ కోసం let us say this is my first person, second person. Random names తీసుకుని చూసుకోండి రా. ఓకే, జస్వంత్ is the first person and రామ్ చరణ్ is the second person. JR, RG, whatever it is. చూసుకోండి. So this is a string, all of you. A string ఉంటే they are holding one strings at the same time. Try to understand, okay? Try to understand how these situations are looking like. So he is holding like this and that he is holding like this. Are you able to understand? ఇప్పుడు చూసుకోండి. What did he do is he actually created a wave and sent it like this. At the same time, ఆ టైంలో కూడా this student అంటే whatever the name, they are having the same waves in the same phase. Same phase అంటే ఏంటిరా? Both are having the maxima. అంటే ఏమైతుంది సార్? సేమ్ phase లో waves ఉంటే when they are interfering, they will interfere in a constructive way. Constructive way ante entira? You imagine the amplitude of this way is A1, the amplitude of this way is A2 ra. Mari when they mix chesina tarvata, the waves when they will meet something like this. So see, this topic is actually too deep ante there are too many things to discuss about waves, but we are not going into all these technical detailities of the functions. Okay, so ఏమైతుంది అంటే when the two waves are forming, the amplitudes will be added up అంటే A1 plus A2 రా. ఇదే కదా. So this is your constructive interference. మరి సార్ for constructive interference how will we talk in terms of mathematics? Mathematics అంటే ఏంటిరా? Mathematics అంటే you try to understand, okay, your whatever wave equation is y is equals to a times of sine of whatever ఏదైనా తీసుకోండి దీంట్లో. You understand your wave is a sine function లేదా cos function. ఇదే కదా. Sinusoidal function ఉంటే sine values are repetitive. Repetitive అంటే ఏంటి సార్? Repetitive అంటే every 2π interval తర్వాత the value of the sine becomes the same. Are you understanding? Yes. So that means if this is your first wave, this is your second wave, they are meeting. Arey చూసుకోండి రే, all of you. So if the phase of this wave y is equals to లేదా y1 is equals to a1 sine of omega t, అదే this is the phase రా. ఇప్పుడు to get the same phase we need the same values కదా. అంటే maxima, అరే చూసుకోండి రా, it is the maxima కదా. Maxima, let us say this is a maxima రా. ఇదే this is a maximum point of the wave కదా. Yes. So maxima happens at pi by 2. చూసుకోండి. మళ్ళీ you add 2 pi to it, ante 2 pi plus pi by 2 ante 5 pi by 2. Okay, 2 pi plus pi by 2 ante 5 pi by 2. For example, you try to understand. Okay, here y2 should be equals to a2 sine of 5 pi లేదా 2 pi plus omega t రా. Okay, 2 pi plus omega t అంటే this value only for sine. Okay, only for sine రా, only for sine. ఇదే they are same అంటే if this is a maxima, this is also be a maxima. Are you understanding? అంటే ఏంటి రా, you add 2 pi to it, you add 4 pi, 6 pi, 8 pi, 10 pi, 12 pi, 14 pi, 16 pi, 18 pi, 20 pi, 22, 24, 26, all these things. When you are adding these values, the sine value repeats ante enti ra, it will take, if it's a maxima at omega t plus 2 pi maxima, interfere, constructive, omega t, same phase. Just a minute. Do you have 7 o'clock?
7 to 10.
But Mithun told me till 10 p.m.
It is actually booked from 7 to 10.
Of me?
For me.
No. Are you sure? I'll just call the Mithun.
No, you can.
Yeah, sure. So, చూసుకోండి. What's happening over here is, all of you. So, if this is your omega t, same phase ఉంటుంది కదా. Yes, add them, constructive, doubt clear. Omega t and omega t plus 2 pi. కానీ sine ఉంటుంది రా. So, for sine, omega t plus 2 pi is same as omega t. Continue, same point. Omega t plus 4 pi, same. Omega t plus 6 pi, same. ఎందుకు సార్? Because 2 pi is the repetitive interval of sine. Getting it? Not getting it, ra? Okay. Perfect. అంటే మీ constructive interference కోసం the phase difference, it could be 2 pi. ఇది చాలా important. Okay, if you are telling this equation as y1 equals to a1 sine of omega t, the second equation should be of this form ra. Y2 should be equals to a2 sine of same omega t ra, same omega t. చూసుకోండి, omega must be same. So omega t plus 2 pi లేదా 4 pi లేదా 6 pi, 8 pi, 10 pi, 12 pi, 14 pi అంటే 2n pi. అదే కదా, 2n pi. So it should be 2 into n into pi. అదే, that means you take the phase difference రా అందరికి. ఇదే, this is my phase phi1, this is my phase phi2. మీరు phi2 minus phi1 గురించి మాట్లాడితే it should be equals to 2 into n into pi. అంటే if your phase difference is an integral multiple of 2n pi, automatically your waves will form in a constructive format. అంటే there will be a maxima from the interference. అర్థమైంది కదా? ఇప్పుడు చూసుకోండి, ఫర్ డిస్ట్రక్టివ్ ఇంటర్ఫరెన్స్. ఓకే, ఫర్ డిస్ట్రక్టివ్ ఇంటర్ఫరెన్స్ అందరికి, ఫర్ డిస్ట్రక్టివ్ ఇంటర్ఫరెన్స్ కోసం యూ కెన్ సింప్లీ సే దట్ సార్ ద వేవ్స్ షుడ్ బి ఇన్ ద ఆపోజిట్ ఫేజ్. మరి ఆపోజిట్ ఫేజ్ అంటే ఏంటిరా? If the first wave is having the maxima, the second wave should have minima, and the two meet at a single point. For example, చూసుకోండి రా, అదే, this is my person Ram, okay, and this is Shamra. Let us say Raju and Kaju, all like this. Okay? Raju and Kaju. What they are doing is, here at the first end, all of you, జాగ్రత్తగా వినండి. మీ ఫస్ట్ ఎండ్లో you have a maxima that is traveling to the right side. కానీ మీ సెకండ్ ఎండ్లో యూ హ్యావ్ ఎ మినిమా దట్స్ ట్రావెలింగ్ టు ద లెఫ్ట్ సైడ్. అంతే కదా? ఎస్. సో దిస్ మాక్సిమా ఇస్ యాక్చువల్లీ ట్రావెలింగ్ టు ద రైట్ అండ్ ఇట్ ఇస్ ట్రావెలింగ్ టు ద లెఫ్ట్. చూసుకోండి, యాంప్లిట్యూడ్ ఇస్ a1, ఎక్కడ వచ్చి యువర్ యాంప్లిట్యూడ్ కన్వర్ట్స్ టు a2 రా. సో వెన్ ద టూ వేవ్స్ విల్ మీట్, ద టూ వేవ్స్ వెన్ దే ఆర్ మీటింగ్ ఏమవుతుంది అంటే the resultant amplitude will be simply the resultant of the two waves. It's a very small. Are you understanding? For example, if you say simply a net is equals to a1 minus a2. What if a1 is equals to a2 ra? If a1 is equals to a2 until your a net becomes 0, that means your wave will become a perfectly straight line. I hope it's understandable ra. Okay. Ardhamaindi andariki? Yes. So this is something that happens when your pattern is following a destructive interference. మరి ఎలా ఐడెంటిఫై చేయాలి సార్? మీ డిస్ట్రక్టివ్ ఇంటర్ఫరెన్స్ కోసం first should be in the positive form, the second should be in the negative form. అదే కదా? Yes. So if the equation of the first wave is y1 is equals to a1 sin of omega t, what should be the equation of the second one ra? Ante it should be exactly the negative. చూసుకో. This term is, let us say, positive x ra. You do some changes such that this term becomes minus x. Ante exactly value should remain the same, just the sign should change ra. Ante you can simply say, sir, sin of pi plus x is equals to, చెప్పండి, what is it? Minus sin x. Ante you do one thing, you add pi to it. Ade, oh my goodness. Ante you can simply say, sir, y2 should be equals to a2 into sin of omega t plus 5 లేదా plus 3 pi లేదా plus 5 pi plus 7 pi. How would you convert these numbers into one single formula? So it should be equals to 2n plus 1 into pi. అదే కదా? n value 1 పెట్టుకోండి, it becomes 3 pi, 0 పెడితే 1 pi. You put n equals to 2, 5 pi and solve this. Ante for your destructive interference, y2 plus 2n plus 1 into pi. Ade. So these are the two phases ra. చూసుకోండి. So when you are talking about delta phi అంటే phase difference ra, phi 2 minus phi 1, phi 2 minus phi 1, phi 2 minus phi 1 గురించి మాట్లాడితే this is your phase difference అందరికి. Omega t plus 2n plus 1 pi minus omega t. అదే కదా? Yes. So your phase difference should be omega t plus 2n plus 1 into pi minus omega t. Omega t, omega t gone. Your phase difference should be 2n plus 1 into pi, and it should be your delta phi. Whenever your delta phi is coming as 2n plus 1 into phi, that means it is a destructive interference. లేదంటే if it is coming 2n pi, it is a constructive interference. చూసుకోండి, ఇది చాలా చాలా ఇంపార్టెంట్. ఓకే, all of you. So let me just classify once again ra, if it's a constructive interference అందరికి, లేదా if it's a destructive interference. Okay, if it's a destructive interference, constructive interference unte, you can simply say, sir, change in the phase difference must be equals to 2 pi, 4 pi, 6 pi, 8 pi, something like this. Ekkada destructive interference unte, your change in the phase difference must be equals to 2n plus 1 into pi. అదే కదా? డెల్టా ఫై అంటే ఏంటిరా? డెల్టా ఫై అంటే ఏంటి? ఇప్పుడు లెట్ us take a general form. ఓకే, జనరల్ సినారియో ఆఫ్ ద క్వశ్చన్స్. మీ జనరల్ సినారియోలో యువర్ y1 షుడ్ బి ఈక్వల్స్ టు ఈక్వేషన్ ఆఫ్ అ వేవ్ a1 టైమ్స్ ఆఫ్ సైన్ ఆఫ్ ఒమేగా t మైనస్ k ఇంటూ x1. వాట్ అబౌట్ y2 రా? y2 షుడ్ బి ఈక్వల్స్ టు a2 టైమ్స్ ఆఫ్ సైన్ ఆఫ్ ఒమేగా t మైనస్ k ఇంటూ x2. ఇదే కదా? ఎస్. చూసుకోండి, అంటే దిస్ ఐఎమ్ కాలింగ్ ఇట్ యాజ్ phi 1, దిస్ ఐఎమ్ కాలింగ్ ఇట్ యాజ్ phi 2. అందరికి జాగ్రత్తగా వినండి, చెప్పండి ఇప్పుడు. సో డెల్టా phi ఈజ్ ఈక్వల్స్ టు, కెన్ ఐ సే సింప్లీ ఇట్ ఈస్ ఈక్వల్స్ టు phi 1 minus phi 2 రా? phi 1 minus phi 2. So from here I'll simply say, sir, phi 1 minus phi 2 is directly coming as k into x2 minus x2 రా, x2 minus x1 రా. చూసుకోండి, ఇదే కదా? ఎస్. సో మీ ఫేజ్ డిఫరెన్స్ డెల్టా phi అంటే చూసుకోండి, k into x2 minus x1, డైరెక్ట్లీ సబ్స్టిట్యూట్ హియర్ రా. టెల్ మీ. So for your constructive interference, చెప్పండి, what is your delta phi, sir? Constructive interference కోసం this delta phi should be equals to 2 into n into pi, అంటే k into delta x. చూసుకోరా, k into delta x should be equals to 2 into n into pi. What is k, sir? k is equals to, what is k ra? What is k ra? k is v by omega. గుర్తుందా? k is v by omega. Omega by v. Sorry. Omega by v, sir. Sir, k is omega by v into delta x is equals to 2 into n into pi. అదే కదా? v is what రే? What is v? What is v? 2 pi f. 2 pi f. Yes. Sir, v is, sorry, omega is 2 pi f. Sorry, omega is 2 pi f. v is f into lambda. అదే కదా? ff gone. So k is 2 pi by lambda. ఇక్కడ నుంచి you can simply say, sir, 2 pi by lambda into delta x is equals to 2 into n into pi. That means your delta lambda లేదా your delta x should be equals to, చూసుకోండి, I'll write the equation itself. చెప్పు, 2 pi by lambda into delta x should be equals to 2n into pi. ఇదే కదా? pi gone రా. So from here delta x upon lambda should be equals to n కదా? Yes. So your delta x should be equals to n into lambda. ఇది చాలా 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 ఇంపార్టెంట్ కండిషన్ ఫర్ ద కన్స్ట్రక్టివ్ ఇంటర్ఫరెన్స్. అంటే ఏంటిరా? యువర్ డెల్టా x should be equals to n into lambda. మరి వాట్ ఈస్ డెల్టా x, సార్? వాట్ ఈస్ డెల్టా x అంటే ద పాత్ డిఫరెన్స్. ఇప్పుడు చూడండి, This delta phi ante me phase difference ra. Delta phi ante me phase difference, and when it comes to delta x, it should be your path difference. I'll tell everything, don't worry, okay? I'll tell you simply. Delta x is your path difference ra. For your constructive interference, చూసుకోండి మళ్ళీ ఒక్కసారి ఫైనల్ గా రాస్తున్నారు అందరికి. For your constructive interference, me path difference must be equals to n into lambda. What is lambda, sir? Lambda is the wavelength of the wave. ఇప్పుడు this wavelength is not in our hands ra, okay? చూసుకో. This is something that is the relationship between your path difference and the wavelength. కానీ for destructive interference, let me write once again ra, చూసుకోండి. For your destructive interference, what can I say is your delta phi should be equals to 2n plus 1 into pi by 2. 2n plus 1 into pi. అంటే your 2 pi by lambda multiplied by delta x should be equals to 2 into n plus half multiplied by pi. అదే ఇదే కదా? Yes. 2 pi gone ra. Ante what you can say is your delta x must be equals to n plus half into lambda. Ade. So this should be your path difference. Okay, this should be your path difference, all of you. Right? Perfect. ఇప్పుడు these are the small conditions, okay? These are the very small conditions. చూసుకోండి. When I'm talking about the mathematical equations now ra. ఇప్పుడు I'm talking about the mathematical equations. గుర్తుందా? Superpositions of SHM ra. Superposition of SHM. What did we say over there, sir? ఇదే మీ first SHM is A1 times of sine of omega t minus k into x1. మీ second SHM అంటే y2 should be equals to A2 times of sine of omega t minus k into x2. ఇదే కదా? Yes. When you're adding these two, మీ net resultant equation, it comes out something like this ra. Go to SHM. Do you remember in SHM what did we write ra? We simply say, sir, A net into sine of omega t plus some constant phi kada? Yes. We did not take kx1, kx2. You can take if you want. You can simply say, sir, it should be simply equals to phi. అదే. ఇప్పుడు let's talk everything about it రా. చూసుకో. A net అంటే ఏంటి రా? A net అంటే your resultant amplitude అందరికి. Okay? Your resultant amplitude. Are you understanding? Yes. Resultant amplitude ఒకసారి ఫార్ములా చెప్పండి రా. A net is equals to root of A1 square plus A2 square plus 2A1 A2 into cos phi. What is cos phi, sir? ఈ కేసులో మీ phi అంటే this is the exact phase difference that you are having రా. చూసుకో. సో ఈ కేసులో మీ phi is equals to k into x2 minus k into x1. phase difference కదా? That means k into in bracket delta x రా. k into delta x అంటే k is 2 pi by lambda. ఎప్పుడు చూసినా కదా? Yes. So your phi is nothing but 2 pi by lambda into delta x. అందరికి చూసుకోండి. This is the phase difference that I am having for now. Are you able to understand? Are you able to understand or not understand? రా చూసుకో. అదే. వెరీ గుడ్ sir, వెరీ గుడ్. అంటే this is the equation. Hey, now ఇప్పుడు I can say this is the equation. ఇది equation ఉంటే your A net is equals to root of A1 square plus A2 square plus 2 multiplied by plus 2 into A1 into A2 into cos phi రా. ఇప్పుడు I want you to observe for maximum interference అంటే for maximum value of A net రా. అంటే A net కి maximum value కావాలంటే what you do is you put the cos phi as 1 రా. అదే కదా? cos phi equals to 1. If the cos phi is 1, ఎందుకు సార్? Because the maximum value of cos phi is 1. You're substituting. అంటే your A net becomes root of A1 squared plus A2 squared plus 2A1 A2 cos phi is 1 కదా? అంటే you can directly say A net is equals to root of A1 plus A2 whole square. That means simply equals to A1 plus A2 రా. అదే. So this is your A net. A net అంటే net amplitude అందరికి చూసుకోండి. ఇదే మీ maximum కి కండిషన్ ఇదే రా. ఇప్పుడు let us talk about the intensities. What is the formula for intensity, sir? Intensity I is equals to గుర్తుందా? 2 pi square f square a square rho v రా. That means you can simply say, sir, I is directly proportional to a square. స్క్వేర్ రూట్ తీసుకోండి సార్ అంటే a is directly proportional to root I ఇదే కదా ఎస్ సో దాట్ మీన్స్ a is directly proportional to root I an అంటే root in ఎందుకు సార్ బికాజ్ a is directly proportional to root I you understanding yes should be equals to root of I1 plus root of I2 so this is the maximum condition ra ide the condition for your maxima ledante for any general case you can simply say sir root of I net is equals to root of A1 square is ante I1 plus A2 square ante I2 plus 2 into root of I1 into I2 into cos phi చూసుకోండి this is any general condition for intensity okay general condition low your intensity లేదా your net intensity depends on the independent intensities by this formula అందరికి చూసుకోండి okay these are the formulas for your minima రా చూసుకోండి minima కోసం what you can say is for your minima you can simply say sir minima కోసం your a net is equals to root of a1 square plus a2 square plus 2a1 a2 into cos phi అంటే మినిమా కోసం ఫర్ మినిమా your cos phi should be minimum అంటే ఏంటిరా మినిమం అంటే -1 అర్థమైంది అందరికి -1 ఉంటే you can simply say sir your minima a net is equals to root of a1 square plus a2 square minus 2a1 a2 into cos phi లేదా it should be -1 ఇదే కదా yes -1 so ఇది -1 ఉంటే you can simply say sir root of a1 square plus a2 square minus 2 a1 into a2 అదే minus 2a1 a2 అంటే ఏంటిరా a1 a2 అదే minus 2a1 a2 అంటే root of a1 minus a2 whole square అంటే this is your a net so you can simply say sir a net is equals to a1 minus a2 అదే that's what we have told in the beginning రా చూసుకోండి when it is a maxima you understand ra what did I say when it is a maxima what did we say ra a net is a1 plus a2 కదా చూసుకో maxima కోసం let us go to back చూసుకోరా ఇదే మినిమా కదా డిస్ట్రక్టివ్ ఇంటర్ఫరెన్స్ కన్స్ట్రక్టివ్ అంటే మాక్సిమం చూసుకోండి a1 a2 యువర్ నెట్ ఆంప్లిట్యూడ్ కమ్స్ అవుట్ టు బి a1 plus a2 డైరెక్ట్లీ రాస్తుంది చూసుకోండి అండ్ ఫర్ యువర్ డిస్ట్రక్టివ్ ఇంటర్ఫరెన్స్ యూ విల్ గెట్ అ మినిమా అండ్ మినిమా కోసం యూ కెన్ సింప్లీ సే సార్ a net is equals to a1 minus a2 దీస్ ఆర్ ద మ్యాథమెటికల్ ప్రూఫ్స్ బిహైండ్ ఆల్ ఆఫ్ దిస్ ఓకే ఇప్పుడు ఇంటెన్సిటీ గురించి మాట్లాడాలంటే యూ కెన్ సింప్లీ సే సార్ I net is equals to root of I net is equals to root of I1 plus I2 plus చెప్పండి 2 root of I1 into I2 into cos phi అదే సో దిస్ ఈజ్ యువర్ ఇంటెన్సిటీ ఫర్ మినిమం ఇంటెన్సిటీ అంటే ఏంటిరా అండర్స్టాండ్ ఫర్ అ మినిమం ఇంటెన్సిటీ దాట్ మీన్స్ యువర్ లైట్ ఈజ్ మినిమం దాట్ మీన్స్ యూ గెట్ అ డార్క్ ప్యాటర్న్ రా మినిమా అంటే డార్క్ ప్యాటర్న్ ఓకే ఫర్ యువర్ మాక్సిమా అంటే మాక్సిమం ఇంటెన్సిటీ అంటే యూ కెన్ సింప్లీ సే సార్ యువర్ బ్రైట్ ప్యాటర్న్ రా బ్రైట్ ఫ్రింజ్ డార్క్ ఫ్రింజ్ all these things we will be encountering all these in wave optics okay you have Young's double slit experiment over there also so in Young's double slit experiment lo we will be using this result only ade this is the only result that we will be using ante this delta phi is 2 pi by lambda into delta x ade okay good chusko ippadu kosam for now you can simply understand it is a dark pattern and for minima root of I net is equals to root of I1 minus root of I2 ade you are understanding there was a question asked in JEE mains also in NEET also question is like this if two waves have same intensities and interfere full stop find ratio of the maximum intensity to the minimum intensity I should not say minimum ra I should not say minimum ఎందుకంటే it becomes 0 kada yes let us stay I would not say same intensities okay two waves have intensities I and 2i okay I and 2i full stop and interfere find the ratio of maximum intensity to minimum intensity అదే కదా of the maximum to minimum intensities చెప్పండి. It's a very simple question now. Tell me. Hey, you're getting, you're not getting ra. These are very simple questions. Why are you doing like that? Choose go. Intensity maximum to I minimum is equals to root of I1 plus root of I2 formula ra, divided by root of I1 minus root of I2. ఇదే కదా root of I1 is 2I1 అంటే లేదా 2I only 2I minus root I. Sir, root 2I plus root I ante how much, sir? I am confused, sir. I am confused. Root 2I plus 3I, sir. Root 2I minus root I is root I divided by root 2I plus root I is root 3I. Ide kada? Yes. Sir, root I gone. 1 by root 3 is the answer. Ade kada? Yes. Very good. Very good. Very good. Okay. This is the answer that we got. Right? Root 2I minus I is root I and root 2I plus I is root 3I. We have added it. We got the answer as 1 by root 3. Okay? Yes. Hey, sorry. Maximum intensity positive, మినిమా అంటే ఇట్ షుడ్ బి మైనస్, ఇదే కదా, మైనస్ మైనస్ నెగటివ్ నెగటివ్ నెగటివ్. సో ఇక్కడ నుంచి మైనస్ రూట్ ఐ అంటే ఇట్ షుడ్ బికమ్ రూట్ 2i ప్లస్ ఐ అంటే రూట్ 3i డివైడెడ్ బై రూట్ ఐ. రూట్ ఐ గాన్ సార్, సో రూట్ 3/1 అదే. దిస్ ఈస్ ద ఆన్సర్ దట్ వి గోట్. ఓకే రైట్ రైట్ కరెక్ట్ కరెక్ట్ కరెక్ట్. Wrong answer, wait. It's wrong, it's wrong, it's wrong. It's not root 3/1. చూసుకోండి అదే. That's why your mathematics is required రా. You understand root 2i plus root I is not root 3i. You're understanding? Yes, root 3/1. It's not right. It's not right. It's not right. It's wrong. It's wrong. It's wrong. Hey, root 2 plus root 3 is root 5 ra. Huh? I have to teach basic maths. Yes, I have to teach basic maths, sir. Kabatti root 2i plus root I is root. How can you say this, sir? It's not true, right? It's not true. You understand? Root 2i plus root I అంటే I root I కామన్ తీసుకురా, left with root 2 plus 1 ఇదే కదా. Yes, understanding. And similarly root 2i minus root I, ఇక్కడ కూడా root I కామన్ తీసుకోండిరా, you are left with root 2 minus 1. Understanding? Maxima minima I max divided by I minimum ఇదే కదా. Yes, root I gone. It should be root 2 plus 1 by root 2 minus 1. You understand? Okay, it's a very simple question, all of you. No. Hey, try to understand ra. Okay, ఇప్పుడు time is left, 1 hour is left. Okay, only 1 hour is left. So ఈ 1 hour లో I have to talk a few more things. Hey, let us go for the constructive interference. Okay, constructive interference చూసుకోండి. Constructive interference అంటే ఏంటిరా? That means your amplitudes are simply getting added up. ఇదే కదా. A net is equals to A1 plus A2. Point number 1. Point number 2, మీ equation should be y1 is equals to A1 sine of omega t minus kx1. And your second equation should be A2 into sine of omega t minus kx2 plus 2n pi. ఇది అర్థం చేసుకోండిరా. If this is the format of your equations of the waves, then it is always a constructive interference. అంటే you're simply saying A net is equals to A1 plus A2. If it is not like this ra, లేదా 2n pi అంటే 2 pi plus 4 pi 6 pi 8 pi something like this. So it's always going to be constructive. If it is not constructive, లేదా it's a destructive interference unte, you can simply say, sir, y1 is equals to A1 sine of omega t minus kx1. Second equation should be y2 is equals to A2 sine of omega t minus kx2 minus లేదా plus 2 into n plus 1 multiplied by pi. ఇదే. So this should be the format of your equation. Then your A net will be equals to your A1 minus A2, whatever it's bigger, and ఈ మొత్తంని we will call it as a destructive interference. అదే కదా. Yes, so it's a destructive interference. చూసుకోరా. Here when it's a constructive interference, that means your delta phi అంటే ఏంటిరా? delta phi అంటే ఏంటి చెప్పు అందరికి. delta phi is equals to k into in bracket x2 minus x1 should be equals to 2n pi. Ide kada? Yes. That means 2 pi by lambda into x2 minus x1 should be equals to 2n pi. 2 pi gone. Ikkada nunchi you can simply say, sir, delta x should be equals to n lambda. Delta x is what? Ippudu the biggest question is, what is delta x? So on this delta x, actually we can dedicate one full lecture and 2 hours only on this delta x, but I'm not giving that much of detail. Chusko. We will just quickly go through delta x. The same thing as you do by yourself, and you will find something like this. Delta x should be equals to n minus half into lambda. You are understanding? Yes. So let us talk about delta x. What is delta x, sir? Delta x is nothing but your path difference. Path difference. Choose. Path difference ante entira. Sir, let us say this is my first source. First source ante this is producing a wave. And let us say this is my second source ante this guy is producing a wave. Are you understanding? Let us say these two waves ra andariki. Ee rendutni waves, you can simply say that these two are meeting at some random point. Here they are meeting. Ardhamaindi kada? Yes. So what you will decide is, you will decide simply the path difference ante ఈ సోర్స్ నుంచి ఈ పాయింట్ వరకు డిస్టెన్స్ ఇస్ x1. సిమిలర్లీ ఈ సోర్స్ నుంచి ఈ పాయింట్ వరకు దిస్ డిస్టెన్స్ ఇస్ x2. అందరికీ చూసుకోండి. ఇఫ్ దిస్ డిఫరెన్స్ బిట్వీన్ ద డిస్టెన్సెస్ అంటే డెల్టా ఎక్స్ రా, డెల్టా ఎక్స్ ఇస్ యూ కెన్ సింప్లీ సే x1 మైనస్ x2 లేదా x2 మైనస్ x1. ఇఫ్ దిస్ path difference is equals to n lambda ante it is your constructive interference. Leda me delta x ante same difference ra, path difference x1 minus x2, it is equals to n minus half into lambda. It will be called as your destructive interference. If it is not in these two categories, sir, if your delta x is equals to x1 minus x2 is equals to some random values ra, random values ante enti ra, lambda by 4, it's not constructive, it's not destructive. Are you understanding? It's something else, something else. Okay. Later you can simply say, sir, your constructive interference is 3.3 lambda. Are you understanding? It is not n lambda formula. N should be equals to 0, 1, 2, 3, 4. Try to understand. N lambda ante enti ra? Your delta x is equals to 0, leda lambda, leda 2 lambda, leda 3 lambda, 4 lambda, 5 lambda, and all these things. If this is your path difference, then you will say it's a constructive interference. Similarly, n minus half lambda ante exactly 0.5. 0.5 ante enti, sir? 0.5 lambda, 1.5 lambda, 2.5 lambda, leda 3.5 lambda, so on and so forth. Positive or negative also, minus 0.5, minus 1.5, minus 2.5. Then we will say it's a destructive. Can it 3.3, it's not even in the both formats, so it is not constructive, it's not a destructive interference. General interference is taking place. Ade kada? Yes. So ఇప్పుడు we have something known as number of minima and maxima. Kani I will not take here. We will take that in your wave optics. Okay? Wave optics lo chuddam andariki. So here now let us talk something about your standing waves ra. Chuskondi andariki. Okay? Something known as your standing waves. Hey, before that, chusko. Speed of sound ra, okay? Speed of wave, sorry. Speed of wave on a string. Chuskondi andariki. If this is your string, okay? This string is tight ra. Let us say the tension in the string is capital T. Mu is the linear mass density. Mu ante enti telsa? Mu ante total mass by total length of the rod. Edaina wave you are sending, the speed of that wave v should be equals to root of t by mu. Ela ochindi, sir? How did it come? You don't ask me all these things, okay? Because I'm already too much frustrated. If you are asking me, I'll keep on proving it, okay? I will prove it. But then your headache will be there. Already nobody of you is focusing. You're chatting randomly and you're understand. So this is the speed of the wave. Ante root t by mu, t by mu, t by mu. T ante enti ra? Tension in the string. Mu ante enti ra? Mu is your cheppandi. Mu is the linear mass density. Ardhamaindi andariki? Right. So let us take one question ra. Find the speed of wave for the following assemblies. Okay, for the following assemblies. First case lo, this is your support, this is your mass M, and let us say the mass of this rod is capital M, length is capital N. Second case lo, I'm giving some more questions to you, okay? Second case lo, let us say this take it here only now. Don't get anything else. Try these questions and tell me the answers, okay? Is the pen? Right. చెప్పండి. So, first of all, you calculate the value of mu ra. Mu is total mass upon total length kada? Yes. Tension is equals to mg ra. Ade. So, your speed is equals to root of t upon mu ante root of mg divided by capital M upon capital M. Ante root of mgl upon capital. ఇదే సారీ స్పీడ్ కావాలి కదా. ఎస్, సో ఇదే మీ స్పీడ్ రా ఫస్ట్ కేసులో. సెకండ్ కేసులో చెప్పండి, ద టెన్షన్ ఇన్ ద స్ట్రింగ్ ఈజ్ మళ్ళీ ఒకసారి ఎంజీ కదా. ఎస్, సో టెన్షన్ ఈజ్ ఈక్వల్స్ టు ఎంజీ, కానీ యువర్ టోటల్ మ్యూ ఈజ్ వన్స్ అగైన్ ద టోటల్ మాస్ బై టోటల్ లెంత్ అంటే m/l. అగైన్ సేమ్ రా, సేమ్ టు సేమ్ ఫార్ములా ఫర్ ఫస్ట్, ఫర్ ద సెకండ్ వన్ ఆల్సో. ఓకే, for the first one, for the second one, formula is the same. అంటే వాల్యూ is the same రా. ఇక్కడ చూడండి, టెన్షన్ ఈజ్ ఈక్వల్స్ టు ఇదే అట్వుడ్స్ మషిన్ కదా. అట్వుడ్స్ మషిన్ ఉంటే మీకు ఫార్ములా గుర్తుండాలి రా. ఓన్లీ 3 months left, 100 days left for your exam. You must remember the formulas. Tension value is 2m1 m2g divided by m1 plus m2. అంటే g value is 10, m1 plus m2 is 10, m1 plus m2, g gone రా. 2 into m1 into m2 అంటే 42 Newton. అదే, సో ఇదే మీ టెన్షన్కి వాల్యూ. టోటల్ మాస్ ఈజ్ 100 డివైడెడ్ బై టోటల్ లెంత్ ఇస్ 10 కదా. ఎస్, సో టోటల్ లెంత్ ఇస్ 10. సో 100/10 అంటే ఇదే 10. సో యువర్ మ్యూ వాల్యూ ఇస్ 10. ఇప్పుడు స్పీడ్ ఈజ్ ఈక్వల్స్ టు రూట్ ఆఫ్ టీ బై మ్యూ. రూట్ ఆఫ్ 42 డివైడెడ్ బై 10 అంటే v ఈజ్ ఈక్వల్స్ టు రూట్ ఆఫ్ 4.2 మీటర్ పర్ సెకండ్. అంటే ఏంటిరా, ఇఫ్ యూ గివ్ అస్ వేవ్ in this string, ఈ situation లో అట్వుడ్స్ machine లో, that wave will have the speed of root 4.2 meter per second. That approximately equals to 2 meter per second. అదే చూసుకోరా. నెక్స్ట్, అదే finished. So let us talk about speed of sound రా. సౌండ్. ఇప్పుడు సౌండ్ గురించి చూద్దాం అందరికి. సౌండ్ గురించి ఐఎమ్ టాకింగ్ అబౌట్ సౌండ్. ఓకే, ఆల్ ఆఫ్ యూ జాగ్రత్తగా వినండి. ఇప్పుడు ఐఎమ్ టాకింగ్ అబౌట్ సౌండ్ అంటే speed of sound ra, everything remains the same for sound. Okay, almost each and everything remains the same, but there are some changes. I will tell you. Chuskondi andariki. So if it's a sound, then the speed of the sound will be given as root of e upon rho. Root of e upon rho, sir. What is e? Hey, properties of matter chapter completed. Properties of solids we have completed kada. Yes, ee formula lo we talked about e ante coefficient of elasticity andariki. We talk about E ra. E అంటే your coefficient of elasticity. అదే కదా. ఎస్, చెప్పండి. This is a formula for speed of sound. Speed of sound in solids. Solids ఉంటే this is your formula. E అంటే your coefficient elasticity. 3 టైప్స్ ఉన్నాయిరా elasticity. అదే 3 రకాలు. ఫస్ట్ వన్ ఈజ్ యువర్ యంగ్స్ మాడ్యులస్. డూ యూ రిమెంబర్ సంథింగ్? యంగ్స్ మాడ్యులస్ రా. కోఎఫిషియంట్ ఆఫ్ ఎలాస్టిసిటీలో యూ హ్యావ్ యంగ్స్ మాడ్యులస్. దాని తర్వాత యూ హ్యావ్ షియర్ మాడ్యులస్ లైక్ దిస్ రా. దెన్ యూ హ్యావ్ బల్క్ మాడ్యులస్. గుర్తుందా? సంథింగ్ లైక్ దిస్ రా. ఎస్, దెన్ యూ హ్యావ్ బల్క్ మాడ్యులస్. All this you want to put. If you want to put, you can put it. Okay. If it's a gas, then bulk modulus. If it's a solid, then Young's modulus. Ante kada? It's good. Next. What I was going to say. Yeah. Speed of sound of the gases, okay? And what is rho, sir? Rho is the density of the medium. Density of medium. Next, for gases kosam, the formula changes a bit. For gases, speed of gas is equals to root of gamma into pressure of the gas divided by rho. Ade. Yes, good, very good, very good. Gamma ante enti ra? Gamma is the gas constant ratio of specific heats. Ante Cp by Cv ra. What are these Cp by Cv, sir? We will discuss. Droppers unte meeku gurtundali. If you are not dropper, if you are first time learner, then we will discuss it in your thermodynamics and your thermal properties of matter. Our chapter we will discuss it, okay? Cp, Cv, thermodynamics, KTG lo specifically we will be discussing all these terminologies. Try to understand. P is the pressure and your rho is the density of the material. Ade, I'm not going much into it. Let us talk something about standing waves and then the chapter will be completed, okay? Let us talk something about standing waves. చూసుకోండి. Standing waves in the sense, you have a wave, but I don't know how to tell you. Do I have some tool to explain ra? చూసుకో. Possible I will try to explain you, or else I won't be able to do it. So చూసుకోండి అందరికి. Should I tie it ra? Should I tie it? But I don't know you will see it or not. Depends on the length also. Also depends on the length kada. Yes. So let us say ide. Hey, understand, okay? This is a string ra, okay? This is a string, but I don't know. It should not fall ra, okay? Is it tight? Yes, it is tight. చూసుకోండి అందరికి. Standing waves ante these are the standing waves. Can you visualize? Can you visualize? These are the standing waves, all of you. These are the standing waves ra. Okay, try to understand, okay? Try to understand. If I do like this, are you visualizing? These are the standing waves. Good. Successfully, luckily and successfully we were able to do it. చూసుకోండి. Standing waves ante if you have one wave and if you have second wave, you have to do it. Show you life. అందరికి చూసుకోండి రా. This is a string. I would not call it a string ra, but it's something similar to string kada. Yes, చూసుకోండి all of you. What is visible ra? My hands are not even visible. Taking too much of space, right? Both of the hands should be visible kada. Is it not visible, right? Both of my hands, they are visible kada. Yes, you try to understand, all of you, okay? You try to understand. Let us do like this. Let us say exactly in the middle ra. Chusko. Okay, so these are known as the standing waves. See, try to understand, okay? Only one wave is standing kada. You try to understand. There is a single wave ra. There is a single wave. There are two waves. Would not say two waves ra. You understand. Getting too much confused. Where to come? Which frame to come in? This is the wave kada. What the orientations are ra? Chusko. This is a first standing wave, but it's not a complete wave. It's a half wave ra. It's a half wave kada. It's a half wave. Chusko. But when I rotate this hand too fast ante if I'm increasing the frequency, there are two lobes. Chusko. Try to understand. There are two lobes kada. Yes. At max I can do is to make two lobes. For making 3, 4, 5 lobes, the hand must be moved very fast. And the frequency should be very high ra. Very high. Chuskondi. Standing waves ante enti ra? Me standing waves lo, if this is your string, all of you try to understand, okay? If this is your string, the first wave and the second wave, they will have what type of interference ra? Am I doing? Alright, so this is the speed of sound ra. Chuskondi. You can also simplify it. V is equals to root of gamma into P. Chuskondi. P. What is density, sir? Density is mass by volume. Ade kada. So P into density is mass upon volume, all of you. Ekkada nunchi you can simply say, sir, root of gamma into pressure into volume divided by mass. Ide kada. So there is this ideal gas equation ra. Naku teliyadu if you know it or you don't know it. but we do have this equation PV is equals to nRT. If the number of mole is 1 mole unte, you substitute your speed is equals to root of gamma into R into T divided by mass M. M ante. Are you understanding all these formulas? There are some questions also you can frame. I'm skipping for now, okay? For now, I'm leaving all these questions. Okay, let us talk about standing waves. Standing waves lo, you do have two types of waves that are coming. Ante, there is a reflection of wave. Okay, so before standing waves, we will talk about a reflection of waves. Chuskondi. Why am I feeling too? Basics. Let's keep it up. Basics. Chuskondi. So first, modatiga, we will talk about something known as reflection of waves. Reflection of waves ante entira? Reflection of wave ante you have two types of reflections. Ante try to understand, okay? The first one is reflection from fixed end. Ide kada? Yes. The second one is reflection from free end. Fixed end ante entira? What do you mean by okay? What do you mean by fixed end? That means ide your string. Fixed end lo you tie this string la. Ade, are you understanding? If you are throwing your wave something like this ra, emaitidi ante it will go, it will hit. Hit chesina tarvata what happens is cheppandi andariki, what happens is it will get deflected. Deflected ante the phase changes ra. Phase changes ante enti koncham samayam tarvata chuskondi. I don't know what's happening ra. I don't know what's happening. Your energy seems too low. Too low. Chusko. After some time, the wave goes and hits the wall, kada? Yes, so it is the wave, it is the wall. Now it is just ready to hit the wall, all of you. It is just ready to hit the wall. As soon as it will hit the wall, ante the phenomena happens something like this. Chuskondi andariki. This is the phenomena. That means it has already hit the wall. Did I take too long, ra? Okay, like this. Chusko. It has already hit the wall, ra. Ante endi? Ipudu what will happen ante? At the same time, chuskondi, at the same time, as soon as the complete reflection has been completed, so this is the string, this is a wall, okay, chudandi, it will come back, kada, reflection ante coming back of the wave ra, chuskondi, the wave will look something like this. Are you understanding? And after some time, what happens is, this is your wave. You are understanding? It is coming to the left, coming to the left. Here, the wave is going to the right, going to the right. When it's fixed end, it is in the upper part kada, painari undundi chuskondi. After the reflection, the lobe went in the downward direction. Ante entira? There is phase change. Phase change. I will not change ra. I will simply say phase reverse. Okay, reverse kada, reverse. How much phase difference, sir? Phase difference ante you can simply say, sir, delta phi is equals to, no, it has been completely reversed. It was, yes, correct. Crest reflects as tro reflects as crest. Ardhamainda? Correct. What about if it's a free end? చూసుకోండి, if it's a free end, then what happens is the free end low, the best example for the free end is this is your rod. It is attached to a ring, okay, it's a ring, and this ring is actually suspended with a pole. Are you able to understand? Yes. ఎప్పుడు ఏమైతుంది అంటే you are creating a wave and sending to the right side. Are you understanding, all of you? అర్థమైతుంది కదా? Okay, I'll wipe out this and this. చూసుకోండి. So this is your wave traveling to the right. Perfect. So ఇప్పుడు what happens is this wave will definitely go and hit the pole. But as soon as it is getting hitted, ante complete wave gone into the pole ra. What happens is this ring will go up and come down. Chusko, it will go up and come down ra. Ring will go up and come down. As the ring is coming down, it is step number 1, and step number 2 is like this. Chusko. So as the ring is coming down, the reflected wave, లేదా the reflected part of the wave looks like this. It is coming to the left ra. చూసుకోండి. And what can you say about complete reflection? అంటే ఇదే. This is a complete reflection. అంటే crest becomes crest, trough remains trough. You understanding? చూసుకోండి, all of you. Okay, so this is the condition. All of you try to understand. These are the reflections from free end. That was the reflection from the fixed end. Ante kada? Yes. ఇప్పుడు చూడండి. There are equations also related to the amplitudes. Okay, there are equations also related to the amplitudes. Can I don't want to jump into all those things. Okay, I don't want to jump to all those things. చూసుకోండి. Yes, correct. So if you are combining the strings ra, combining the strings లేదా combination of strings, ఈ strings ని combination ఉంటే, let us say this is my first string and this is my second string. Try to observe. Okay, try to observe. ఏమైతుంది సార్? when you are throwing a wave, చూసుకోండి. It's called as rearer medium. ఇదే కదా? Yes, rearer medium, and this part is known as denser medium. Okay, let me just go quickly and tell you that the denser medium acts as fixed end ra. Okay, and rarer medium, spellings and all things you observe it. Okay, adjust it, acts as free end. ఇదిగో అంటే what happens sir, if I'm throwing a wave from rarer to denser medium, చూసుకోండి రా, ఇదే నా rarer medium and this is my denser medium. Okay, ఇదే నా denser medium. Straight line అదే. సో ఇప్పుడు if I am throwing a wave అంటే this is my wave. జాగ్రత్తగా వినండి all of you. Let us say speed is v ra, amplitude is a. It will go to the right kada? Yes, for sure this wave will travel to the right side. As soon as it travels to the distance, okay, speed v, చూసుకో. ఇప్పుడు what happens is, చెప్పండి all of you, what do you think will happen? There are two phenomena that are happening. First of all, there are two phenomena that are happening: transmission, reflection. Transmission of wave, reflection of wave. Are you understanding? Yes, transmission of the wave and reflection of the wave. So transmission కోసం I am using the yellow color. So this is the transmitted wave. అందరికి చూడండి. So this becomes your transmitted wave. Okay, it is going to the right side. కానీ when you talk about reflected wave, this is your reflected wave. చూసుకోండి. ఇదే. This is your reflected wave. reflected wave, and this is your transmitted wave. What happened ra? Chusko. Crest became trough kada. That means phase difference has occurred by 180 degree. The phase difference is there by 180 degree. Ante it behaves as a denser medium. You are understanding? Are you understanding, all of you? Yes. What if the wave is traveling from a denser medium to rarer medium? Chuskondi. So this is my denser medium and this is my rarer medium. Are you understanding? So what's happening, sir? Ante again malli okkasari here also the same phenomena are happening ra. Chusko. Ide na wave kada. Yes. So if this wave is actually traveling to the right, what's happening is you can simply say there are two more phenomena ra. Chuskondi. The first phenomena is transmission. Transmission ante enti ra? Transmission of wave. Chuskondi. Transmission ante some waves have passed and some wave comes back. Ade kada? Yes. But this end ante rarer medium behaves as the free end. Free end ante enti ra? If it's a crest, remains crest. If it's a trough, remains the trough. Ade kada? Yes. So your transmitted wave looks something like this. Ante this is your transmitted wave. Spelling ra. Okay, this is your transmitted wave. What about the reflection, sir? Reflection ante this somewhere here would be your reflected wave. Green color, chuskondi. This is your reflected wave. Okay? Yes. Idante me reflected wave. So this was all about the reflection of waves. Ardhamaindi? Yes. There are some equations also that correlate. Okay, amplitude A1, A2, A3 ra, but I am not going into it. Sorry. Perfect. Perfect. Ippudu we will talk about your standing waves. Chusko. So these are your standing waves. Ante enti sir? Standing waves lo you understand, okay? Whenever we are talking about standing waves, we take a fixed length of wire between two walls, okay? Between two walls. Yes. No. For the free end, the phase difference is 0, okay? For the free end, where is it ra? For the free end, chusko, it's crest ante phase is same kada, so your delta phi should be equals to 0 leda 2 pi, whatever it's, okay? 0 తీసుకోండి. No phase difference ra. Even if it's there, it's a constructive type of interference. Something you can say it like that also, okay? Try to understand. Okay, correct. The topic is stationary waves. Chuskondi. Stationary waves yeah, you can tell stationary waves also. Stationary waves, they are standing waves. Okay, why stationary waves ante they are not moving anywhere ra. You can do it something like this. Try to understand, okay? Try to understand, all of you. So whenever we are talking about standing waves, what we are doing is we are taking two different walls, okay? E walls keep here. Hey, try to understand. I'm also connecting a rope ante string to this, okay? What happens is I have a combination that I just release it, pluck it. Are you understanding? I just pluck it. What happens is after I pluck it, this string will vibrate something like this. Up, down, up, down. Are you understanding? Something like this. But we don't do it like this, okay? Physics law, you never say you are holding it and releasing it. Na, leda. How do we say it ante? You remove this ra, ee mottamni you remove it. That means one end has been removed. Ade kada? Yes. You stay right there. Okay. Now what you are doing is you are oscillating it up and down. Are you understanding? And there is some frequency, some frequency is there. Are you able to understand, all of you? Yes. There is some frequency. ఇప్పుడు there are certain cases, all of you try to understand. Certain cases అంటే ఏంటిరా, మీ స్టాండింగ్ వేవ్స్లో let us say this is your fixed end, okay? This is your row. I should take a little smaller actually. And we have to take 3-4 cases, okay? 3-4 cases చూసుకో. సెకండ్ కేసులో మళ్ళీ ఒక్కసారి this is your string, this is your wall. Then this is your string, this is your wall. Then this is your string, this is your wall. అంతే కదా? కరెక్ట్, 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 పర్ఫెక్ట్. Wavelength and amplitude same with same speed, opposite direction, superimpose each other. You can say something like this, okay? ఇప్పుడు what's happening is here you are oscillating it, the waves are getting reflected. When they are reflecting, they are forming standing waves, okay? You are oscillating, the wave traveling. Fixed end kada, ee fixed end nunchi the waves are getting reflected, and the reflected and the transmitted wave, they are interfering, superposing tarvata the wave looks something like this. Ante enti, try to understand, okay? Try to understand, all of you. This is my fixed end, okay? This is my fixed end, so I am removing it. It is my free end, so what I am doing is I am oscillating something like this. Chuskondi, okay? I am oscillating something like this. Too much ra. So chuskora, something like this. Are you understanding? Yes. So this is my standing wave. Ante what's happening, sir? Ante you can simply say that the wave that is coming back from the fixed end ra, it is superimposing with the wave that I am passing through this hand, okay? Yes. Sorry. Anyways, try to understand. Ante when you only have a single loop, we say it is your first harmonic. లేదా నేమ్ గుర్తు పెట్టుకోండి రా, ఇది చాలా కన్ఫ్యూజింగ్ పార్ట్. విచ్ ఇస్ ఫస్ట్ హార్మోనిక్, విచ్ ఇస్ ఫస్ట్ ఓవర్ టోన్, ఆల్ దీస్ థింగ్స్, ఓకే? లేదా జీరోత్ ఓవర్ టోన్. We don't say zeroth overtone, we simply say first harmonic, okay? We don't say zeroth overtone, but we say first harmonic. Here, when your complete wave is forming, ante something like this ra, chuskondi. Sometimes the wave goes like this, and sometimes the wave goes like this. You understanding? Yes. This is known as second harmonic, leda first overtone. Next case lo you have third harmonic. థర్డ్ హార్మోనిక్ అంటే ఏంటిరా? థర్డ్ హార్మోనిక్ అంటే 1 2 3 ఇదే కదా? ఎస్. సో దిస్ wrong. You oscillate it quick. But choose, remember, as you are increasing the frequency, the number of lobes increase. Telsa? Right, sorry. And lastly, we need 4 kada? We need 4 points. 4 points kosam 1 2 3 4. Chusko. Are you able to understand, Ra? All of you. This is your second harmonic. Leda, you can also say first overtone. I'm not digging into the equation of the standing waves, okay? This is something known as sin cos, cos cos, cos sin, sin cos. They are in a multiplication. The equation of your standing waves looks something like A sin kx cos omega t. You are understanding? Yes. Correct. ఇప్పుడు దిస్ ఈజ్ యువర్ సెకండ్ హార్మోనిక్ లేదా ఫస్ట్ ఓవర్టోన్. ఇదే అంటే మీ థర్డ్ హార్మోనిక్. ఆల్ ఆఫ్ యూ టూ థిక్ రా, little thin, like this. Sorry. So this is your third harmonic లేదా your second overtone. Lastly, this is your fourth harmonic or third overtone. Perfect? Yes, perfect. Perfect. చూసుకోండి. ఇప్పుడు వీ హ్యావ్ టు టాక్ సంథింగ్ అబౌట్ ద ఫార్ములాస్ రా. ఫార్ములాస్ అంటే ఏంటిరా? ఫార్ములాస్ అంటే ఏంటి సార్? ఇఫ్ ఇట్స్ యువర్ ఫస్ట్ హార్మోనిక్, చూడండి ఫస్ట్ హార్మోనిక్ ఉంటే దిస్ ఈజ్ యువర్ స్ట్రింగ్ and this is your lobes. Okay, there are two terminologies, nodes and antinodes. Nodes ante entira? There are two terminologies. The first terminology is nodes ante points which do not move. Ade kada? Yes, which do not move అంటే the nodes are these points. అందరికి జాగ్రత్తగా చూడండి. This is your first node. ఇదే అంటే మీ సెకండ్ నోడ్ రా. These 2 points are not moving. Whatever is happening రా, the second point is moving. Antinode అంటే exactly in the middle of the nodes. Understanding your antinodes. What is the antinode రా? What is antinode? అందరికి చెప్పండి. What is antinode sir? Your antinode అంటే are you understanding? Yes. Correct. Okay. ఇప్పుడు what we are gonna see is ఈ కేసులో how much wave has been formed రా చెప్పు. అంటే if I have a complete wave అంటే it should start from here. Okay, it should go up, it should come down, మళ్ళీ ఒకసారి it should end at the same place. అంటే this has become my one complete wave. అంటే ఈ పాయింట్ నుంచి ఈ పాయింట్ వరకు ద డిస్టెన్స్ ఈజ్ నోన్ యాజ్ ద వేవ్ లెంత్ అంటే లాంబ్డా. ఇదే కదా? ఎస్. ఇప్పుడు జాగ్రత్తగా చూడండి. ఇఫ్ ద టోటల్ డిస్టెన్స్ బిట్వీన్ ద 2 points ఈజ్ లాంబ్డా, వాట్ ఈస్ దిస్ డిస్టెన్స్ రా? వాట్ ఈస్ దిస్ మచ్ ఆఫ్ డిస్టెన్స్ చెప్పండి. కెన్ ఐ సింప్లీ సే సార్ దిస్ ఈజ్ λ/2? అదే కదా? ఎస్, సేమ్ డిస్టెన్స్ రా. చూసుకో. ఇఫ్ ఇట్స్ అ కంప్లీట్ వేవ్ ఇట్ షుడ్ గో డౌన్ అండ్ కమ్ బ్యాక్ కదా. బట్ ఇట్స్ నాట్ అ కంప్లీట్ వేవ్, ఇట్స్ అ హాఫ్ వేవ్ ఉంటే what you can say is, let us say the total length of the wire is L ra, length of the string లేదా wire లేదా rope, whatever you want to take. Okay sir, the length is equals to half the wavelength అంటే λ/2. ఇదే కదా? Okay, what is lambda ra? For a given wave, what is lambda? Sir, speed of a wave by frequency. అదే కదా? Yes, so lambda is nothing but speed of wave by frequency into 2. అదే కదా? What is the speed of wave in a string? చెప్పండి. Sir, speed of wave in a string is given as, what is it? Correct. The speed of wave is given as root of t by mu multiplied by 1/2f. Are you understanding ra? అంటే your length is equals to 1/2f multiplied by root of t by mu. That means if you want to find the value of frequency ra, so ఇక్కడ నుంచి your frequency comes out as 1/2l root of t by mu. అంటే ఏంటిరా? you substitute these values, మీకు ఒక frequency వస్తుంది. That frequency అంటే number of oscillations per second. You do it, you will exactly get one loop. Are you understanding? You will exactly get one loop. కానీ it is for the first overtone. చూసుకోండి, ఫస్ట్ హార్మోనిక్. I'm sorry. This whole scenario లేదా ఇది ఈ మొత్తం ఫార్ములా it is only valid for your first harmonic. Are you understanding? ఓకే, మరి మీ సెకండ్ హార్మోనిక్ కోసం వాట్ ఈస్ ద ఫార్ములా చూద్దాం అందరికి చూడండి. సో ఇఫ్ దిస్ ఈజ్ యువర్ points, okay, and this is actually the length, but you have successfully created two lobes ra, something like this. Are you able to understand? Are you able to understand, all of you? ఎప్పుడు can I say that the total length is equals to the wavelength of the wave, lambda? ఎందుకంటే the complete wave has been established. అంటే ఇప్పుడు you can simply say, sir, the total length is equals to total lambda. Ante L is equals to speed of wave divided by frequency. Ante L is equals to speed of wave is root T by mu ra, divided by frequency ante 1 by f. Ikkada nunchi you can simply say, sir, frequency is equals to 1 by L root of T by mu. Ide kada? Yes. This is for the second harmonic. For the second harmonic, all of you. Next, for the third harmonic ra. Cheppandi. For the third harmonic, this is your fixed end. Ide kada? Yes. This is your fixed end. Ide kada? Yes. And this is a string ra. Ide. This is your string. Chuskondi. There are third harmonic unte, there will be three different lobes. Hey, tell me the number of nodes ra. Here the total number of nodes is 3. Chusko. Number of nodes ra. Ide. This is the first node. This is your second node. This is your third node. Antinodes, they are 2. Ade kada? Yes. So number of nodes is equals to 3. Too thin ra. What is this happening here today? Okay. The total number of nodes is equals to 3, and the total number of antinodes is equals to 2. Ardhamaindi? Okay, perfect. Now, when we talk about the third harmonic, leda, the second overtone, it's a second harmonic, leda, your first overtone ra. Okay, try to understand. Second harmonic, leda, your first overtone. Ade kada? Yes. Chuskondi. So in your third harmonic, you will have 3 different lobes. Ante enti ra? It looks something like this. Everybody. Are you understanding? Yes. And goes like this. How many waves? How many waves? Chusko. Idi lambda by 2, lambda by 2, lambda by 2 ante 3 lambda by 2 ra. Total length is equals to 3 lambda by 2 ante L is equals to 3 by 2 into lambda. What is lambda, sir? Lambda is equals to speed upon frequency ante 3 upon 2f into speed v ante your length should be equals to 3 upon 2f times of root of T by mu. Ekkada nunchi you can simply say, sir, frequency is 3 upon 2L times of root of T by mu. Ade. Ide kada? It's your third harmonic ra. Third harmonic. Leda your second overtone. Second overtone. Chuskondi. Can you observe some relationship re? All of you. Cheppandi. If it's a second harmonic, it is 1 upon L. 1 upon L ante enti ra? 2 upon 2L. Ide kada? Yes. If it's a first harmonic, 1 upon 2L. Second harmonic, 2 upon 2L. Third harmonic, 3 upon 2L. If it's a nth harmonic, cheppandi, nth harmonic unte what should be the frequency? If it's the nth harmonic, what should be the frequency? Frequency is n upon 2L root of T by mu. Chusko. Okay? So this is something, the formula. Nth harmonic ante there will be n lobes ra. N lobes unte how many nodes will be there and how many antinodes will be there? It's depending on you ra. Question is, if it is nth harmonic, how many nodes and antinodes, how many nodes and antinodes will be there? Question. Yeah, చూసుకోండి. Oh, thank you so much. Thank you so much. How many nodes and antinodes will be there? And also you must, hey, meeku gurtundalira ee mottham formulas, and all of these we have done for the fixed end kada. If it's a free end, then the story changes. You understanding? Fixed end always acts as a node, but your free end always acts, your free end always acts as an antinode. Chusko. This is the length L. You reflect whatever you want to do, you do it. Okay, the waves, if it's a first harmonic, the wave looks something like this. Understand? Okay, the free end always acts as the antinode. So that's a homework for you. Okay, find లేదా derive a formula for the free end. Free end అంటే free end of the rod. ఎందుకంటే we don't have much time left. Okay, right. So are you sure? Are you sure? Correct. So this was all about the waves chapter. Chuskora. What did we discuss? Let me quickly go through the revision. Then we will be completing this chapter. Sorry. So the first topic that we discussed was our SHM. SHM nunchi we talked about the equation of SHM. Then we talked about the superposition of SHM. And you have 2-3 SHMs, how do you superpose them? Based on the same thing, we took multiple particles. In multiple particles, they are performing in SHM, and it will become a wave. Yes. We also talked about the general equation of a wave, that is y is equals to a sin omega t minus kx లేదా plus kx depending upon the axis. X axis unte kx, y axis unte ky, z axis unte kz. And wherever the wave is traveling, it should be x, y or z correspondingly. That over there we talked about speed of wave, then we talked about speed of a particle of a wave, then we talked about the slope, we talked about the relationship. What did we say is, we also saw where the particle is moving currently. If you are given a wave, you are given a position of the particle, if it's moving up or down, it should be completely understandable. Okay. What did we discuss is, we talked about the energy of a wave. Yes, we talked about kinetic energy, then we talked about potential energy, we talked about the power of the wave, then power nunchi we went to intensity nunchi we talked about the interference of the waves. Interference lo we talked about constructive interference, destructive interference. Constructive interference lo there should be a condition on the phase difference that it should be equals to 2 n pi, ante there should be a condition on the path difference, it should be equals to delta x is equals to n lambda. Lambda, 2 lambda, 3 lambda, 4 lambda and all these things. If it's a destructive interference, there is a phase difference condition, delta phi should be equals to 2n plus 1 into pi. That means your path difference should be equals to n minus half into lambda, లేదా n plus half into lambda. Whatever you want to take, you can take it. Okay. We talked about the minima and the maxima conditions. If it's a minima, then A net will become A1 plus A2. If it's a maximum, then A net becomes A1 plus A2. If it's a minimum, then A net becomes A1 minus A2. Similarly, if the condition for the intensity is also, if it's a maxima, then the intensity will become root of I1 plus root I2. If it's a minima, then root I1 minus root I2. Ade kada? Yes, dan tarvata we talked about the reflection of the waves. If it's a free end, then the free end will be keeping the same phase. If it's a fixed end will be reversing the phase. Ade kada? Yes. So that means the phase difference is pi. And dan tarvata we talked about the reflection and the transmission of the waves in the complex types of ropes. And then we talked about your standing waves. Standing waves happen when you continuously keep on oscillating a wave. That wave goes, it goes and gets reflected from that end. If it's reflecting, then the two waves do superimpose. Dan tarvata whatever pattern you are getting, you are telling that as a standing wave. Standing wave lo kuda you have different harmonics. First harmonics unte there will be a single lobe ante 2 nodes, 1 antinode. If it's a second overtone ante you will be second harmonic. Second harmonic unte you have 2 lobes ante you have 3 nodes and 2 antinodes. Ade kada? Yes. And if you have third harmonic ante there will be 3 different things. 1, 2, 3, 4 nodes will be there and 3 antinodes will be there. Ante kada? Yes. In your first harmonic leda, your 0th overtone, you only have half wave ante your total length will become lambda by 2. Lambda is speed upon frequency. Speed is root t upon mu. You can simply say your frequency should be equals to 1 upon 2l into root t by mu. For the second harmonic, 2 by 2l into root t by mu. For third harmonic, 3 by 2l root t by mu, and so on and so forth. Okay. So this is all about your frequencies and this is all about your lengths. in order to make the standing waves do work well. So ఇప్పుడు I want all of you to remember each and every formula. I've told everything, quickly summarize చేసిన కదా. Yes, so the way I am able to tell everything without seeing any notes and pen and paper, you must be able to tell the same things about the waves chapter also. Not about the wave chapter, for each and every chapter, okay, for each and every chapter you must be having the same knowledge in your hands. You understanding? Fine. So with that being said, we will be taking the next session on wave optics. Wave optics ante idi chala important topics. It might take somewhere around 6 hours of class for us to complete that. Okay, ఒకసారి your wave optics has been covered, the chapters that we are left with, the first chapter is heat and thermodynamics, ante thermal properties, thermodynamics, KTG. Ade, if that is also completed, you are only left with your modern physics and one more chapter from your oh my goodness, beat frequencies, f1 minus f2. Although it's look a very complicated topic, you remember, okay, beat frequency fb is equals to f1 minus f2. ante entira, if you have two tuning forks, you hit it, you have the frequency swing, 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 swing. You hit it, you have the second tuning fork, you hit it, swing, swing, swing. f1 f2, you take the value of the subtraction f1 minus f2, then that would be the beat frequency. Ante when you are talking about that, something like that, okay, you do it, okay. Anyways, it's a very simple topic, beat frequency ante beats is a very simple topic. Ante you have two different waves, they are topping and their maxima minima coming. Okay, we will take it later on, all of you, because I do have one more class now at 8:30 andariki. Okay, sorry. So if that's clear, then we can end this session andariki, right? Sorry. Good night all of you. Good night. Repu we will be having wave optics, and then we will be having AC currents, AC chapter, alternating currents. Then only two branches left, the first is heat, the second one is modern physics. Your physics entire chapter will be completed by this month only, mostly by this month, but if the time does not allow me, then by the first week of the next month, anyhow the chapters will be completed. Okay, don't worry, okasari go and watch my lives from the beginning, and then you come back again here. After the syllabus will get completed, we will be starting with your PYQs, continuously PYQs, last 40 years లేదా last 20 years, including your GE mains. Okay, perfect. Good night. Yeah, magnetism and matter is there, and your AC is there. Sorry. Okay, fine. Sorry, your syllabus has been completed, we will be taking PYQs. Okay, good night all of you. Good night. Bye bye.